Recording already? Wow. Where did it go? There it is. Oh, look, the sun came up.
Hi, John. We can see you pecking away at something there. I
Um,
thought you had welder's glasses on for a minute, but you got your magnifiers on, yeah?
yeah, no, I'm
Well, I can't hear
trying
you. Wait till
to.
I get my, I'm having trouble with my audio, I think. Here, let me see.
Oh no.
Okay, there we go. Got it working.
Yeah, I'm peeling the clear plastic insulation off of 14.2 wire insulation to add as a tip for this.
Oh, yeah. Well, that looks interesting.
And when they're done, you get a pen that looks like that.
Hmm. That's what is it, a plastic tip? Or that's the insulation there, you mean, of the wire?
Yeah, it's just you just take the insulation that you strip off the wire, and it's got this clear plastic coating on it.
Yeah. So
And
is the wire a little bit further up from the plastic? Is that the idea? The actual wire itself is there somewhere? How far away? Whoops, your video just went
well,
out. Hang
there's
on.
no wire in the insulation at all. It's just empty. It's what I stripped off to make the
Right.
these.
Okay, but is there you've got a nano-coated pen tip inside there somewhere, right?
Well,
Inside.
there's the other one. I got one
Have
here
to
for that.
see a picture of the instead of the thousand words, it'd probably be better.
There's one I haven't assembled yet.
Right, so you've got the nano-coated rod that comes all the way to the end there, and then how far away would the insulation be? Another quarter inch of insulation between it and the half inch or something?
Well, this tip right here, just protrudes from the end of the pen. So I take the little piece of insulation and I glue it back on like that.
Right, I see. Got it. So you got it, it's about what, half inch, or how far would the tip of the pen be from a surface that you put not the tip of the tip of the wire be from the surface when you put it down, you actually use it. It's about a
The wire is
couple
right there,
centimeters.
quarter inch maybe.
Oh yeah, maybe less than a centimeter even.
Oh, quarter inch.
10 millimeters, say, centimeter, roughly.
No, 6 millimeters, 5 or
Okay.
6 millimeters, somewhere in there. That's on a straight line, right? Like
Yeah,
going straight line, but on the side you can get within whatever the thickness of the insulation is.
right. Yeah, cool.
Could be 1 mil.
That's a good point. You could use it in close quarters, so to speak, on the sides where the insulation is.
But these ones I'm going to be giving to Reiki practitioners as tests.
Perfect. Yeah,
And
you should be sensitive to that kind of thing.
that was my thought. And rather than just call them, I'm not going to call them health wires. I'm going to call them intention wands, um, because I don't think that these can be used strictly for health. I think you can use these for anything you want to direct energy with.
Right, I think so too. Can we start it on live stream and get your comments and stuff? That'd be great.
Sure, yeah, you just ask me questions because I may
Yeah.
not remember what I just said.
Yeah, right, exactly. So that's why we need to record it because I don't remember which. It's all in the moment for me, and my moments have been very hectic lately. So I'm just trying to put everything together.
All right.
Anyways, we might as well start recording, and that way we'll have it recorded. So I'll start the live stream here. Check this. Is working. Somewhere there it is. Okay, just getting the live stream. Getting the live stream fired up and zeroed in here. Just be another minute of fiddling and diddling.
Oh no, there it is. Okay.
Yes, that was John.
I hate dropping stuff in the
Spilling
screen.
acid in his lap. He'll be doing the lap dance shortly.
Lab.
Lab dance, we call it.
Yeah.
Lab dancing. When you
So
put
I hate
pour
dropping stuff in
acid,
the screen.
when you pour caustic down your pants, so it's called lab dancing. Get it? You'll be running into the shower pretty quick. Okay, I don't know how we get off on that, how I got off on that foot, but anyways, let me get my sound up. Did that get recorded? I guess so from my end, but not from the other end. Okay, so we're having trouble with speakers audio. Give me a sound check there, John. I need to have a
Testing 1 2 test. That's peaking at 0 dB.
having a bit of issue here, so I have to go. Oh, I see. Okay, could we try that again?
Test 1 2 check.
No. Still having trouble with that one. Let me try again. There, that guy should do it. Go ahead.
Check.
Oh, that looks good. All right, just 1 second. Then reconvene here. Okay, get that one. Hello, testing. That one's good. And testing on the other channel. Go ahead, John, again.
Check 1 2.
All right, perfect. Lovely. All right, on that note of checking, and with John's lovely face and beautiful microphone in our view here, we'll begin the Keshe Plasma Reactor group for Tuesday, August 18th, 2015. And for tonight, we've got Guy has got a full repertoire of things that he wants to present. Oh, no, I'm sorry, Guy. That was wrong person. Somebody out there has things they want to present, and we will see from them. Because I was too rushed to get my act together, and I have things I'd like to do in the background here, perhaps while we work, and I can maybe show some stuff, but we shall see as we go, I guess. So we'll play it by ear as we always do here. Anyway, we can hear from John. That's the main thing right now because he's in our picture, and I wanted him to speak about some of the things he's doing there with this coil arrangement. Go ahead, John.
Well, if you followed from last week, as the stomach turns, I'm working on these health coils, or the health rods that they brought up last week. And I made 4 of them, and I got them all nano-coated, and they look really nice. These are dual coil, a rod with 2 coils around the outside. Oh, I put a whole bunch of information on the websites and stuff. And right now, I'm just encapsulating them so that when I'm done, they look like that. And you take the tip off, and you've got your little wand that you can aim your energy just like that. They don't come apart because they're all glued together. If anybody wants to know what's in them, I'll tell them how to make them. But the best use I've ever found for dry erase markers. And I'm just in the process of putting some more together. Here's one that's half together.
Okay, nice.
I have some plastic
Nice.
tubing. That some people are using this kind of plastic tubing, but all of my tubing has all got this curve to it, and I can't get that curve out, which annoyed me. So I went and spent a buck at the dollar store and bought 4 dry erase markers, and I'm scavenging those. Now I want to give a couple of these, 3 of these away to Reiki practitioners in the area and have them do a test because they already work with this energy, and they would be very sensitive if to the different uses that this could be put to. And I just want to offer it to them and say, give it a try, play with it for a couple of weeks, and let me know how they work.
Okay, now You mentioned something about you weren't going to call them health. What again?
Well, the health rods, I guess they're health pins that they were talking about, health wires
You
on
mentioned you weren't going to call them
last week.
health necessarily because they could have so many other uses, I believe you were saying.
Well, yeah, the way I'm looking at these, the intuition that I'm getting is these these little devices are um, intent amplifiers. You can infuse them with a lot of different things. They're not just for health. They collect energy and they put the energy out. You program that energy with your intent. So I'm thinking some of the tests I want to do. I'm thinking make a glass of water taste like strawberries, or well, anything to do with energy that's not going to step on anybody's free will, because that wouldn't go very well at all. Like I wouldn't use it. I wouldn't take it to the bar and seduce girls with it. But uh, anything you can do. I want to see if I can move water. If I can create ripples on a surface of water. Change the taste of water. Clean some water, perhaps. As well as the health aspects of it, and just see how far you can take the energy that you're pumping through these things and what it can do.
What about seducing girls at home? Is that okay as opposed to at the bar?
If they're okay with it, then that's fine. But usually, if it's at the
If
bar, they
they're
don't know what you.
if they already want to be seduced, then I guess you don't need the magic wand anyways.
That usually how it works. Yeah.
Okay, so more seriously, so maybe one could actually start, if one had command of this magic wand, start um, maybe working with some ordinary electronic systems and sort of giving them plasmatic energy or taking plasmatic energy from them. I'm thinking maybe it could be coordinated somehow with either a simple crystal radio circuit or a more complex thing like a motor vehicle. And maybe there's a way it would actually be able to interact with the electronic structures and magnetic structures within a vehicle if it had enough
Maybe.
impact.
One thing that did cross my mind was your little magnetic field detector.
Yes, right.
If you could take one of these things and get it to play a song, or even just make a beep, would be a huge breakthrough, because then you're taking direct brain energy filtered through the plasma of your body into this direction device and directing it into something that would be a immediate validation of telepathy, telekinesis.
Yes, exactly.
And what Moran, it seems that what Moran is aiming us towards is he's getting us away from the reactors, he's getting us away from GANs, he's getting us away from the matter stuff, going directly into the plasma energy, which is
That's
just
right.
our intent.
Yeah, essentially, intent and intention and your presence and so on is all becomes the criteria then, rather than the aluminum shell of the spacecraft and whatnot. It becomes a different
Yeah,
set of things.
yeah, because we live in a sea of this energy. It's everywhere. It permeates us. It's everything. It's like asking a fish for a glass of water. We're in it. This is our environment. So let's learn to actually manipulate this environment properly.
Yes,
Hey,
exactly. To that end, you can see where we got here. This here is in the way, so I have to put it like that, I guess. There, it's better. This is called a brain power super beacon, and it's got two crystals on the top here. These are tourmaline crystals encased in copper wire coils They're attached to a crystal radio circuit inside the box. And these are more or less nano-coated over the years. They become sort of blackened instead of having that nice shiny coppery thing to them. Here are the two hand grips that you hang on to. They're attached with alligator clips to and plugged into one end of the box. And like I say, it's called the brain power beacon. So what you do is you become one with the circuit in a sense, in that you hold the hand grips, and basically there's a number of different ways it can be used. But since it's tuned to the Schumann earth harmonic, 7.8 some odd hertz, or at least it used to be a few years ago when this was made, you become more or less attuned to that brain wave frequency, which happens to be the theta brainwave frequency. We have alpha, well, beta, alpha, theta, and delta are the main ones. And it helps you to tune in to that theta brainwave frequency, which is the place where telepathy, psychic powers, the tuning into the subconscious and all of its knowledge and abilities and so on can be helped with crystal technology. And a crystal radio is literally, oh, I don't have this on my camera on live stream.
Oops.
There, hopefully these guys will play well together. Oops. Yeah.
Hey guys, this is Zork here. Can you hear me okay?
Yeah, you're coming through
Yes.
good.
Yep. Hey, so I think you're touching on something here with the frequency of light. So if we can program the GANs and the coding of these coils or pins or whatever you want to call them with the right frequency of light, then we can have a good intent on what to do.
Yeah, or we could expand it a little more and say the frequency of the magravs, perhaps, which because the light may or may not be in the visible light spectrum, it could be, you know, way off in some spectrum that we're not used to seeing and so on, as opposed to light, unless you mean light in the terms of the electromagnetic spectrum a little more broadly.
No, and in the plasma frequency level, yeah, sort of Mike Nashif touched on it, right? Sort of where we're heading and where we need to learn. We're sort of programming the light, plasma light frequencies through the nano-coating and the GANs combination with caustic. And then if we can coat these pens with the right potions, I suppose is what you call them, then it sort of determines what your intent is with the pen. If it's healing, is it something else, or whatever it is?
Right, exactly. And it's the nano coating that makes a huge difference, because if you look at these devices, here's another one, for example. This is a smaller, let me see if I can show you sort of the camera's at a high angle here. It's a little box, wooden box, two antennas. And again, it has a very simple crystal radio circuit inside. It's a little blurry there. Hello. Not sure why my camera's not focusing right now too well. In any case, the crystal radio circuit inside you can control a little bit with the capacitor and so on. But that crystal, that tiny little diode crystal, you can barely see it here. It's at the tip of my finger, that little shiny thing there, two skinny little wires and so on. So it's a very small, tiny wee piece of germanium oxide crystal, basically, and that's why they call it a crystal radio. So it's, again, similar to our copper oxide crystals, which is what they are when it comes right down to it, the nano coating, which if you wish to, you could take a copper, a piece of copper and turn it into the same thing as that diode, as that germanium diode in this radio you can take a piece of copper, like a copper penny, and it will act exactly the same as a diode. You could use the copper penny and that's nano-coated and exchange it for the diode, for the actual germanium crystal diode inside of one of these crystal radios,
Well,
and
why
tune it
not
in.
go right back? Why not go right back to the beginning, where when the diodes were first created, the single point diodes that they made, these things are massive. They were, like you need a device to hold them up. But the same deal, but make that with the new concepts with the nanotechnologies.
Well, it's not, nano is not new because actually the first diodes were copper oxide.
Yep.
So, and the first batteries were copper oxide and caustic and zinc. That's what powered the first submarine.
Hmm.
50 batteries, these wet cell type batteries, basically with copper oxide, caustic, and zinc. And they would have to recharge the copper oxide by taking it out and reheating it to when it turned black again and sticking it back in the battery. They had
Yeah,
recyclable batteries even.
anybody that's looking at science or electronics or any of those fields, they can see that that those fields have been heavily controlled for a long, long time,
Hmm.
and they're controlled so that we don't find out this stuff. So if
Well,
we want to
that's
learn it,
part of it.
right back
But
to the
the other
beginning.
part is that it's a different ball game now because we recognize the nanotechnology part of it. It's not just a black oxide coating, which we
Yeah,
could never really tell the difference between one black oxide coating and another black oxide coating. They all look the same. Even put them under a regular microscope, they're going to pretty much look the same and so on. But only under the nano microscopes they have today, even only in the last couple of years, and sometimes even in the last few months, have they been able to start accurately looking at these nanostructures and then actually trying to figure out why is it they have these special properties, and then from there trying to actually make the nanostructures in the image that you want to, with all the little soldiers lined up exactly the way you want, with little nano pyramids or nano rods or nano threads or whatever, nano clumps in some cases. It's like a whole new ball game, because now we have these new tools of yes, it's still, you throw the copper in with the caustic and a few other things, and bingo, you have this process. But you can also, decide to control the temperature to within 1 degree, and control the atmosphere, and control all the conditions. And you can find that you can actually control the nanostructure in different ways. And when it becomes very cheap for us to have a look at those nanostructures, then we'll go, oh, I see this one technique ended up with really cool pyramids all over the black copper surface. And this other technique was more of a wide bandwidth all over the place, but able to absorb all frequencies, even though it was a jumbled up mess of rods and pyramids and cubes and every other geometric shape you can imagine. So I think that as time goes on, we'll become more and more tuned into exactly what we want to create for whatever particular use, because now we sort of just nano coat, and are we sure it's the right coating? For example, Mr. Keshe took a month to 2 months or more to nano coat the inside of some of the copper reactors, because that's what it took to grow the nano layers. And I was just reading about one experiment where they got it down to how many microns per hour the nano layer grew, basically, or how many per day, and so on. So anyways, it's a whole new ball game. It's a $1 trillion industry now, and we just sort of graze the surface with it all and do it in sort of a funky way in many ways. But whatever is adequate to get the job done is the best way until we become more efficient. Like the first solar cells may have been 2% efficient. Now they're up to whatever 30-40% some cases, and growing even more. So depends how far you want to take it, I guess, is one of the things about that. How technical do you want to go? How much do you need to get your cell bead cell battery plasma battery thing to work a little more efficiently, a little better, a little more voltage, a little more amperage, and so on. That'll be the trick of it, because people that have been making batteries have been doing it a very long time, and batteries are one sort of realm, but to approach it from the plasmatic point of view, I think that's what gives us all here an advantage. If we approach all of the different technologies from a plasmatic point of view, it gives us a different insight, gives us a sort of a handhold on how to approach it in a way that might be easier or make more sense. Anyway, I'm done yakking for now. I think somebody else should start yakking.
Yeah, John, just back to your point on attracting women. I just posted a link for the top 10 natural herbs for attracting women's libido.
Boosting a female sex drive. Well, that's fine, but you have to have the female somewhere in your vicinity, usually, unless you mail them herbs or something, I suppose. And
no, so what
they aren't boosting their sex drive on someone else other than you. I don't know. I don't want to go there. This is about plasma and nanotechnology. If there's some herbs that boost your plasmatic structure, which is essentially what some of these probably do.
Yeah, that's what I'm getting at. So you put these herbs in your caustic with and make a custom Gans potion with your caustic, and then you spray and nano-coat your pen with that potion, and then that's your intent.
Right. Mr. Keshe has mentioned this, and it's probably not a very good idea in general to be making those kind of love potions, because what can happen is if you put your or someone else's DNA into it, then that's it. You put someone else's DNA into it. So all of it goes into it, and therefore the bad stuff as well as the good stuff could come through. So if someone, for example, had cancer, then and it was in their DNA, then you try to use that love potion on someone else, it might backfire and give them the cancer instead, or something like that. So generally, karmically speaking, it's not good to mess with the love life, especially of women, I find. But let them make their decisions. They do all the deciding in relationship anyway. And, as far as the love potions go, well, just some of the perfumes today are enough to overwhelm any special love potions or wands out there, I think. And you can get heavily intoxicated by just the alcohol content, let alone the toxic elements involved in some of these perfumes. I know I became allergic to my ex-wife's perfume, and that was kind of a mess. Imagine explaining to your ex-wife how you can't handle her smell anymore.
Please go. Don't go away, man. Just go away.
Yeah, something like that, or else I will. So anyway, I don't know how we keep coming back to our relationships with women here. Maybe I have something to say about that or something, but in any case, back to plasma. That's what it's all about. Where are we here? What do we have to share about that?
Well, one of the questions that came up last week and never really went anywhere was the actual process at doing the ping pong balls.
Doing the ping pong balls.
coating the inside of the ping pong balls because there's been a
For
lot
which purpose and so on? Like which?
for reactors.
Okay, so what kind of reactor again? I'm not
Well,
trying to be.
if you look on, I understand your questions. If you look on the Facebook page, there's lots of people that are gluing ping pong balls to computer fans and using them for reactors.
Yes, yes, I know exactly what you mean. If I could find the ping pong ball that fell off, I'd show you the one that I was about to glue on myself.
Yeah, the thing that's
He's
coming
about to
up
supply me with a ping
usually
pong ball.
is how do you get your nano coating on the inside of the ping pong ball?
Well, that's like the old question from the Cadbury's caramel. How do they get the inside, the gooey stuff on the inside of the chocolate?
Yeah,
And
it's
that
a
was
type
a
of
big question in the ads for a very long time. And you're right. How do you nano coat the inside of a simple plastic ping pong ball? And that is a bit of a dilemma. And I have pondered that for quite a bit. And there is a number of solutions, so to speak, because solutions are the solution. So there's a number of different solutions. I think you're about to say use caustic inside. Is that right?
well, anybody who's done any of this nano coating with the copper, they realize the first bath does absolutely nothing. Your copper comes out clean and shiny. It has no coating
Okay,
on it.
well, wait a minute. So you say it does absolutely nothing, and then the
Oh
next
no,
sentence you say it comes out clean and shiny. So it obviously does something.
yeah, okay. So that's
Okay, well, I would put forth that as the most important step of the whole process is that first cleaning of the surface. But go ahead.
anyway. But my point is the bath doesn't do the coating. It's
Right.
the
It
vapor.
initiates the coating though. And it's
Uh
the
Possibly.
initial seeds, the initial seed coating of your surface is the most important factor because whatever geometric shape you see the surface with will be replicated, duplicated from there on in the vapor bath.
Okay.
So if you create little nano pyramids, then in your vapor bath, you'll have nano pyramids that duplicate and replicate over the surface. And they'll have a certain property that's really magical and special when you look up nano pyramids. Or you can have nano rods. And if the first things you create are rods in that first bath, then in your vapor solution, you'll create rods or ribbons or threads, or in case of copper, you could have cubes rather than pyramids. You can have rods, you can have hollow cylinders, you can have a whole host of different shapes, or you can have them all mixed up because if you don't give a shit, then basically they end up all mixed up. Or if you combine different processes, then yeah, you'll have the nanorods and you'll have some zinc nanorods and you'll have some uh, maybe some aluminum oxides and all these different oxides, which could be good. You might want a broad spectrum nano coating that's totally black and absorbs all wide spectrum of frequencies, for example. Or you might not. You might want a narrow spectrum or a wide spectrum of absorbing, but a narrow spectrum of emitting. And that's what I would put forward is more important, is that narrow spectrum of emitting. Because if you can make nano pyramids or nano rods or nanotubes or even nano threads that are all on the inside of the sphere, but they also, all of them point inward toward the center of the sphere. So if the tips of those pyramids or rods or whatever pointy things that are, when they become energized and release their energy, it'll be like little miniature lasers shooting toward the center of the sphere, which is where you want your plasma and free plasma to be taking place. So to me, that would be a goal in the coatings, would be to have a coating that basically acts as little miniature lasers shooting the magnetic energy or the plasma. Essentially, it's the plasmons, the plasma, the plasmatic structures at the tip of these pyramids. When you look into it, essentially, it's like little smoke rings that you could actually shoot off the tip into the center, but not smoke, but instead plasma. And so that would be a goal, I would think. And if that is the goal, then that very first process of how the surface is prepared becomes important, and what kind of material it is and so on. However, there's the other thought of, if you just want to nano coat it and get it over with, then caustic should work, to either with vapor or with the plain caustic, and then you're going to have a vapor after that, unless you rinse it for at least 5, maybe even 10 minutes straight with water, flushing completely inside and flushing it out, not just letting it sit in there, but flushing continuously. Then you won't get the caustic off that inner surface so easily. It'll be there, and it'll be part of the process that's always sort of taking place a little bit. If there's too much on there, it'll eventually weaken the plastic, because it'll eventually weaken things. And if you want to create a vacuum in the ball, which is one of my processes, then you don't want to be weakening the structure. It's hard enough to create a full vacuum in a ping pong ball to start with. But if you don't care about that, and you don't care about it blowing out in the side, which happened to one experimenter recently, I'm not sure what happened there, but the entire side of the ping pong ball bulged out like it had overheated from rotating inside of a zinc and nano-coated copper can, basically. So who knows what can happen that way. Back to your question, nano-coating the inside. So you could see, like, it's been talked about nano-coating plastic with caustic. Basically, we'll nano-coat it. It'll cause a surface that starts conducting, and so on and so forth. But what do you want to do with your ping pong ball? What's going to be inside? Is it going to be GANs? Is it going to be dry GANs or wet GANs? Is it going to be a lot of it, a little of it? Is it going to be water inside? Is it going to be air? Is it going to be vacuum? Is it going to be only gases, such as the inert gases, or nitrogen? Or there's so many possibilities just in a ping pong ball alone. There's a universe of possibilities, literally probably millions of combinations you could use. So it's a matter of what you want to do with it, and then rotating it on these little fan jobs here. I break off the blades so they have less resistance, and then there's a number of ways to mount them on, none of which has been totally adequate in my mind, but they all have their ins and outs, so to speak. Some of them literally with a hole in the ping pong ball. Oh, thank you very much, Guy. Just on time with the props here. Something like this, for example, where the ping pong ball is epoxied onto the fitting. This is a brass pipe fitting with a brass tube here that goes into it's a little hard to see, all this blackness here. Lighting, that's it. There we go. Into this bearing assembly here. So the whole thing rotates like this. You can stick this in a wooden block or a plastic block or anything you want to hold it. There's 2 bearings inside here. I used skate bearings in this case. That is, as in skateboard type bearings. And then in the other end here is a way to access the gases inside through a septaseal, which can be, you can use a needle through that and put gases in. You can create a vacuum inside here now with this seal, and then just inject any gases you want, and so on. So there's ways of doing it. There's the other way is this way. Thank you, Key, with the props. With your standard bottle cap, which is kind of sneaky. And you cut it off, and then you get centered here. you glue it on. I've used crazy glue, or sorry, not crazy glue. Hot glue can work, and also certain epoxies. You got to be careful. Some epoxies will tend to peel off the ball and not work. What really works good is what's called goop, shoe goop, marine goop, GOOP. It is deadly, and that's what this is. You can't get it off the ball too easily.
Yeah,
Sorry,
Gorilla
go
Glue
ahead.
too.
Sorry?
Gorilla Glue works really, really good too.
Does it? I found that stuff when I used it a few years ago. It went all bubbly on me.
Yeah.
And
Oh
so,
no, it does. It foams up, and you got to plan that. You put a very, very thin little, just a film on your pop bottle, and press it on to the ping pong ball. But once they're together, they don't come apart.
is that right? Okay, well, that's good news. I was disillusioned because I used too much and all bubbled up and went all crazy on me. So I called it crazier than crazy glue. So we'll but the thing about this particular setup is once the cap's glued, or once the neck is glued onto the ball, then what I did is, or what I tend to do, is I glue this cap onto the surface of the rotating fan, right? And then you can actually take your ball and screw it onto this part that's already glued down, and you're good to go. Sideways view. So the thing about the way I do it is I also have glued inside here a septaseal. So now I have needle access to the inside of the ball. So if it's already nano coated and you don't want to expose it to air, and you have a vacuum or other gases in there to make sure it doesn't oxidize, or you maybe want it to oxidize and so on, you seal it. This is sealed just with hot glue all around it, actually. Oops, get in the picture here. And that plastic seal, it's about a little more than an eighth, less than a quarter, 3/16 of an inch thick. That is a few millimeters. And it forms a vacuum tight seal even when you pull the needle out. So that's why I use that as part of this system, which is kind of cool. Once everything locks in on that, it twists in really nice and tight. And if everything's centered, that's the whole deal, is to keep everything centered so it doesn't wobble when you put it together. In that sense, it's nice to have glue when you do the final gluing, to have glue that you can move just a little tiny bit, and you have a couple of minutes at least before it totally sets. So crazy glue is not the best for that kind of thing. Crazy glue doesn't always work anyway. It tends to break at the worst possible time. Okay, any other comments or suggestions about all that ranting? Shall we move on to another rant? Now, okay, well, we could get back to the topic of John. You mentioned how to nano coat the inside, or was it who was it that mentioned about the inside of the ping pong ball, actually how to nano coat it and so on?
Well, I brought
John?
up last week that one possibility would be to have your caustic solution in a stainless container that you can boil and blast the steam into the ping pong ball with like aquarium tubing.
Right, yes, exactly. And uh, that could very well work. um, Yeah, that could be one way of doing it for sure. I think that would be an efficient way of doing it. I don't think it would take too much of the caustic steam, especially if it was in that enclosed surface and just left in there for a while. Some people have done it, have used the straight caustic and left it in the ball, like the liquid, for a couple of days, and then put the vapor in and left the vapors in there for days as well. I don't think it needs that much for the plastic to obtain that basic nano coating, but it's difficult to say. I haven't seen any what do you call it? Microscopic, electron microscope type views of the surface that we get on a ping pong ball, especially, and not the outside, but the inside of the ping pong ball. That you'd have to cut it apart and then get it in the microscope and have all that take place before it reacts to the air too much. If you have it excluded from an air environment and so on and so forth, it's becomes a tricky deal. It's like Keshe was talking about his reactors one time and saying, well, if they take my reactor sphere apart and try to see what's inside, then basically the coating destroys itself when it's exposed to air, and the secret keeps itself. Which is really a good point. You can imagine your disappointment in finally getting the power source for a flying saucer and take it all apart, but because you exposed it to oxygen and nitrogen and a bunch of other things, it destroyed the nano coating immediately, and you were never able to analyze it after that, or get the unit to fly again. So
yeah, because with the copper, you've got a direct feedback. You can look at it and go, yeah, this is coated, this is a nice coating, this is not a nice coating. You can see it. But all of the
you can
stuff that I got with
see it.
plastic, I other than it gets kind of a matte finish, I don't really see a significant difference in the plastic.
Well, that's right. And the best coatings, as Keshe has reminded us, are number one, they're very thin, and number two, you can't see them because they're only a few atoms thick. So not the best coating. I mean, some particular coatings. For example, what do they call it? DLC, diamond-like coating. If you look up that, it's a process that's only atoms thick, but it makes steel so it doesn't corrode. And basically you have a graphene layer on top of the steel, and it's enough to prevent it from corroding, and it's gives a nice shiny surface, and everybody loves it, and it's tougher, stronger, and repels water and all that. So that's an example with just a few layers is enough to do it. And in many of the processes now, if you look up a thin film construction of thin film type sensors and that sort of thing, they use copper oxide, they use all the different oxides, but in a very, very thin film. And it has to be only a few atoms thick, because if you have multiple layers, it stops working. So if you have a really delicate sensor, it requires these thin film technologies to use them where you don't want multiple layers and so on. So depending on what you want and the effect you're trying to get, it gets kind of tricky that way. Another example is in automotive world, and to coat various engine parts. Do you want to dissipate the heat with a certain nano coating, or do you want to contain the heat with another type of nano coating? Do you want to make something so it's reflects, or does it absorb? And you can do that with different kinds of nano coating. Sometimes it's the same material, it's just the way that it's done is different. So it's a pretty tricky thing. And if we work backwards from what is it you want to end up with? What do you want your ping pong ball to do? Do you want your ping pong ball to light up? Do you want it to light up only at night? Or would it light up in the daytime too? Or would it collect energy in the daytime, light up at night? Would it collect energy at night, light up in the daytime? All right, so you don't want a lighting ping pong ball. You want a ping pong ball that's part of the spaceship configuration, 4 balls arranged in a tetrahedral shape and so on, and the fields interacting and so on. Well, you got to create the fields first, Is that going to be with GANs? Is it going to be with nanomaterials? Is it going to be with a pure plasma inside? Is it going to be with high voltage? Is it going to be with low voltage or no voltage or what? And then what's going to be the purpose of your 4-reactor setup? Is it to create lift? Is it to create energy? Is it to create both? Is it to not create anything and be a nice art object to meditate on and to be able to travel through the universe as a Voyager without any physicality? So all these sort of generalized questions are part of the process of just gluing on a ping pong ball onto the neck of a bottle. This is like, if you buy your ping pong balls through the dollar store, which I don't recommend, they're probably not the best quality, but I do anyway sometimes just for experimental purposes. And so you get 6 of them for $1.25. That's like 20 cents each. And the neck of the bottle, well, yeah, you have to buy the bottle, but hey, they're free. You can always get them somewhere. The set to seal is expensive. That might be $1 or $2 for that, but you don't even have to use that anyway. So you end up with this reactor for $1 or $2, basically. Same thing with these little fans. They're $1 or $2 by the dozen. And the battery for $1 or $2 or whatever. So all of a sudden you've got this little rotating reactor for under $5, let's say. But what to do with it is the really, really big question. What the heck do you do with it? And everybody has a slightly different idea. You could tell someone, if you do this, this, and this very, very exactly, you'll get this nano coating surface and it'll be correct and it will work. And I bet at least 9 people out of 10, well, they'll go, oh, okay, I see, I understand that. So because I understand, I'm going to change it a little bit. Instead of doing this, I got a faster way. I'm going to put my copper in the fire and just do the coating that way instead of spending a month and a half like Mr. Keshe does on his reactors. Because that seems like it takes so long. Okay, and then you fire up your reactor and you find out, oh, it doesn't work. Why doesn't it work? I can't understand it. I did everything right. I nano coated it. I put this in, I put that in. So obviously it's a scam. Okay, well, I would say obviously if you were the first person to make a integrated chip instead of a transistor, and you just took a bunch of transistors and melted them together and thought you now have an integrated chip and wondering why it doesn't work, I don't think it's going to work that way. So we have to learn more about the technology, and if we want to really take it seriously, then we'll have to either learn what the coatings do by looking at them and figuring out the different geometries and technologies involved, or maybe by sheer intuition, sheer direct access of the knowledge, which may be an equally valid and simpler, easier way to do it than doing all the testing. So the jury's out on that little bit. I think I'll wait till I see the little floating reactor in front of my face moving around and actually working with full control. And I would say that's probably the correct process for that person in that time and space. And who knows whether it'll work on the other side of the planet or the other side of the universe. But if they do it through intuition, then so be it. That's a valid way. And if they do it through sheer science, well, that's another way, and probably valid as well. If it gets you to the point of achieving lift. You have to throw heart in there somewhere, that that's done with the right intention, and I don't think it will be possible to do actually with the wrong intention in some ways.
No, I don't think it would work at all.
If you have gravity instead of levity in your heart, you're not going to get off the ground, Fred. Sorry, Fred, I didn't mean to malign any Freds out there. Won't get off the ground. Joe. No, not Joe. No. Sir, you won't get off the ground, sir. Will not do. No, that doesn't work. That doesn't include women. You won't get off the ground, period. How's that work?
Yeah, well, so far everybody who's been seeking the elusive lift and actually succeeded, the first thing they had to do was fix their roof. So
You mean their brain or their roof of their house?
roof of their house.
And then they fix their brain shortly after that, I think.
Yeah.
Because that would be enough to fix most people's brains. Having that go through your roof when you had it bolted down to the shop bench, that would be interesting and would probably get the juices going, let's say. The creative juices going.
Yep.
But we don't want to see anybody hurt, that's for sure. But so far, the main, you have to watch out for flying caustic and occasional flying reactors as they come off their pedestals. So far, I don't think any have gone through the roof. A few wives have gone through the roof from their husbands experimenting, and vice versa as well. Some husbands have, that the wives have left to go to join this crazy teaching and so on. So, if people go through the roof, things go through the roof. That's when it gets interesting, doesn't it?
Yeah. Well, last week Moran mentioned that we got several people around the planet who have actually achieved this. So I'm very curious to hear their stories.
Yes, indeed. Well, it's interesting that lately the Cyril group have also decided to sort of pool their resources with the Keshe Foundation and try to come to some common understandings and whatnot. So I think there's some validity in their approach, although they seem to be a little obsessed with the magnets, which is a little too much of the physicality, I think. But if we can understand through the magnets how to manipulate the fields, and then we realize, hey, we don't need the magnets, we just need to use electromagnets. And then we start to say, oh, we don't need electromagnets, we just use our brains and hook in that way, and we can control and manipulate the force where the electromagnetism came from. And it's way easier than going through all this bull malarkey. So this is where Keshe is pushing us more and more, is the way I see it. Go ahead, sorry.
Yeah, it's like Otis Carr brought up years and years ago with his Utron. All you got to do is you take a piece of matter and spin it fast enough, you will get a magnetic field. It doesn't matter what that matter is.
Right, and not just a magnetic field, but a magnetical gravitational field. This is the thing about it. It actually gets into the gravitational part of that. Normally, we just create the magnetical with most of our contraptions and so on. We don't get into the gravitational because we don't know how to control that or measure it and so on. But it turns out you can actually measure the gravitational field of virtually any rotating sphere or any rotating anything for that matter.
Yeah, which kind of makes me wonder, is the maggrav field in that instance generated or released, I should say, by the atomic stress you're putting on the structure? By unbalancing it, putting that odd centrifugal stress into the system, you're going to unbalance the atomic structure within it slightly. And is that enough? Is that all it takes? I mean,
What would that unbalancing do in your visualization? What would be the result, next step after that unbalancing inside, say, a rotating spherical reactor?
okay, well, if you were to look at it as a gas form, I think it would probably be really easy to see as when you start with a gas, say a nitrogen gas. If you spun that fast enough, you would have enough energy or enough pressure created from the centrifugal force to actually create a solid nitrogen material on the outside. The atoms would compress. They would
On
distort from
the
their.
on the inside of the sphere, that's what you mean by outside.
Yeah, if you're spinning it in a sphere, or
standing at the center of the sphere, for example, where we were told the center of the axle never spins.
Yeah,
But go
if
ahead.
you
Yep.
had, say, a disc of iron, very pure iron, I wouldn't really recommend doing this because iron will not stay together at these kind of speeds. This is just a thought process, a thought exercise. If you
Yep.
had a disc of iron, say a foot in diameter, and you spun it at 500,000 RPM, the outside edge of that is going to compress heavily. If you could keep it together, if you could keep it from flying apart.
Well, this is the thing: is it compressing or is it actually decompressing in a sense? Is it expanding or contracting at that point?
Well, that's what I say. If you could keep the outside rim in place, so it
Well, you
doesn't go.
can't because the atoms are actually flying off at that point.
I realize that this is just a thought process.
Yes, that's my thought. Obviously, because I haven't done, but this is a big thing to me because I spent years thinking about this as I was developing a Tesla turbine and thinking of the disc just the way you're describing a metal disc going at, yes, up to 500,000 RPM. And what occurs in the forces in that kind of situation? What happens at the tip of the disc? What happens to the either fluids or gases that pass alongside that disk as it rotates?
Yeah.
You know, what kind of what happens to the situation? For example, I'll just quickly run by in a Tesla turbine with disks inside. If you use it um, basically with water and air at the same time, the water will stay on that outer edge. It'll just keep rotating around the outer edge without working its way back to the central exhaust of the turbine because it's too heavy to go back to the center where all the lightest things are. So yes, that's what occurs. I think, Michael, are you trying to show us something there? What do you got in your picture? Oh, it's something else in front of your screen there, I guess. Or are you holding something? Let me, oh, you don't have your microphone hooked up, so you're muted as such. You'll have to hook up your microphone, I think, through the, right, he's learning to use Zoom, he says here. You can access your microphone mute button. Actually, you can't mute because your microphone is not hooked up. You have to go into the preferences and then click on the microphone settings in order to get it to show up. So I know you're trying to get our attention there. I'm not sure what you can also talk in the chat, and I'll pick up on that too, Michael. He says he's here in the background. Right on. Good. Okay, good. Sorry, let's get back there, John. Sorry, I didn't mean to interrupt. But
yeah. In the case of a spinning disk, you're going to have both. I think you're going to have both. You're going to have some of the atoms are going to be compressing, and some of the atoms are going to be trying to be ripped apart.
well,
So
yeah, what you get actually is very extreme shear forces at the tip of that rotating disc, and you'll get, for example, a laminar kind of situation where one layer will be at one speed, very, very high speed. The next layer closer to the wall of the container will be at a slower speed. The next layer slower still, and the one next to the wall will be still, basically. So there's a gradient there, and the gradient can be so high in the case of the fluids in a Tesla turbine that it will shear virtually any material, any solid or any gas gets sheared into its finer components, you could say. So it's possible to create those conditions where that the shear force between the laminar layers, because of such high, like you say, pressure, but at the same time there's this ripping apart action going on because of the shear action, the vortexes that are created between these laminar layers are so extreme that they literally rip atoms off the off of any element.
That's sort
So
of
this
just
is a very similar concept to let me just interject briefly there. Similar to the concept of the layers of plasma in front of a craft, that one layer is going one way, one layer is going the other way, and then another layer going the other way again, at many, many times the speed of light, perhaps, enough so that any particle or any element that gets involved with that field either bounces off immediately or it gets disintegrated and becomes, part of the field immediately. Either way, it's not much of a choice point because the action would happen very quickly. With those interacting fields that would be required as essentially it's a force field. That's the way it would be. That's the only way you'd be able to travel in space. I guess it's pretty obvious, but that's anyway. Go ahead. Sorry.
Yeah, no, your description of the laminar shear forces sort of reminded me of what Moran was describing with the gas reactors. When you have
Yes. Yes.
your hydrogen and helium at the boundary layer, where they're constantly interacting at that boundary layer.
Yes, that's where all the action happens actually at the boundary layer. It's the same as our simple GANs collection apparatus. It's the boundary layer between the nano-coated surface and the solution that it's in, or it's the boundary layer between the air, the atmosphere, where the CO2 and nitrogen and oxygen are, and the environment of the container. And that boundary layer where the interface between the two is actually more important than the one material or the other in a way. And that's how you create gold nanoparticles, is through that interface. You put a certain material on that layer of water and you can actually create custom DNA molecules and all this kind of thing, just because they get pulled through that active layer.
Yeah, and Moran was saying before about one of the problems that people are having when they're filling their ball reactors with GANs is that they don't get that slip, they don't get that boundary layer, and which again brings me to think that the the maggrav free plasma that we're trying to create is in some sense or in some way a function of the distorting of those atoms at that boundary layer. When you start putting stress on the atoms and you either push the electron closer to the proton or the electron field closer to the proton field or drag them farther apart a little tiny bit, it's going to it seems to me that that is going to release energy, and that may be the trick that we have to really think about when we're working with these energy reactors or the free plasma
Yeah,
reactors.
yeah, I agree, and it may end up that it's not the actual rotation of the sphere that's as important as the rotation of the plasma inside the sphere. I guess that should be an obvious idea. But we keep thinking that we need to rotate the sphere at, 3, 4, 5,000 RPM. I've had the ping pong ball going as high as 10,300 RPM, and I probably could have gone double that. But does it do any good to go to higher RPMs to get more gravitational effect? The gravitational effect is quite extreme. You can get easily 100 G's force inside a ping pong ball or a rotating sphere, and you can go up to many more G's force than that quite easily. And by G's, I mean we're under 1 G force right now. That's the weight of your body. Is, say you weigh, I don't know, 100 kilograms, then that's going to be the weight that is pulling down at 1 G force. If there's 2 G's, you would weigh the equivalent of 200 kilograms. If there was 5 G's, you'd weigh 1 metric ton, and so on. If there's 100 G's, that's a lot of force on these particles, and normally it would take a very, very heavy atmosphere to compress the particles to that extent, or it would take extreme event in space to compress particles to that extent. So just by doing that, we're creating a special environment, I guess you might say, by spinning things on planet Earth here.
Yeah, that I originally started thinking that it was the spin and the centrifugal force distorting the actual structure within that, and that allowed the free plasma to go. But now I'm thinking it's probably not the outward force pushing everything to the outside of the ball that's doing it. It's the variation in the speed gradients within that ball that's doing it.
Right. Well, that's a good point. And with the original patent, now, one of the ideas with the spinning is, like you say, to create the separation of the gases in layers. And each gas, in that sense, had its own peculiarity, its own job to do in terms of the central plasma, in either converting the rays down or um, creating the fields themselves in the central core and so on. So in that sense, and they were very specific layers in that the you know, xenon gas and krypton or helium and hydrogen and so on. They're all specific. The argon, um, they all had a specific job to do inside that particular reactor, and to keep the whole plasma going, essentially. So in that sense, whether we have GANs or some other material in there, um, we have to learn how to create those layers such that they are self-sustaining. And there's many kind of concepts about that too, uh, combining some of the modern science with what Keshe says. There's a few different angles we could talk about as far as that goes. But yeah, okay, so you mentioned the layers, and the friction or interaction between each of these layers. You believe that that's more important, the gradient between them, I guess, is more important than the actual layers themselves, you could say.
That's what it seems like to me. And if you could do that with, say, a flat jet of hydrogen flowing over a flat layer of helium, and still get that free plasma generation, that would bear that out. I don't think the sphere is simple. It's easy. It's a relatively cost-effective way of doing this. But if we could do it with just flow, I mean,
Well, that's entirely possible.
nano-coated
Especially
that same way. I mean,
when you
nano-coated that same way
consider,
to the atmosphere, and if you get free plasma showing up at the wingtips, then we know it's the boundary layer that's doing this, and it's not the sphere itself. And you can do that with a model airplane, I suppose. You can get 100 miles an hour out of a model airplane.
have you seen the new plasma trucks, semi
Uh,
trucks?
I haven't seen them.
I mean, have you read the article about that?
I'm familiar with the concept. Yeah.
Yeah, they use a dielectric. There's a company, let me see if I can find the name for folks here.
I'm wondering if I could apply that to my bicycle and get rid of the headwind.
Well, absolutely. It's called plasmastreamtech.com. Let me try to get it up here on the we have flying objects going on in the shop here. It's moths all over the place. He's trying to catch them. If only we could learn to fly like these moths. My God, we'd have it made. You'd be flopping around a bit, but hey. Okay, let me see if I
Go to
can
the
get.
light. Don't
I
go to
have
the
to go.
light.
Let me see if I can get. I got so many windows going on here. Let me see where we are. Here we go. Share screen. All right, can you see the screen there?
Yep.
See if the folks at home and on the live stream can see. I think so. Okay, I don't have to hold up this ping pong ball anymore. So it's called plasma stream. Their new technology is they use what's called active flow control system using plasma actuators, developed at the University of Notre Dame. So what they do is they control the flow separation around the vehicle. So the main drag force on a vehicle is from the flow separation, which is basically all the vortices and turbulence that's generated due to all the unusual shapes and the way the wind hits it along in the vehicle and so on. And they've used everything from spoilers and plates and diverters and so on over the years, and they all kind of work a little bit. You see cars with these spoilers on the back and different, even minivans with a thingy wing on the back. Station wagons have had them since the 1960s. But the difference here is it's a plasma actuator, and when they ionize the airflow, it's similar to these wings, but it's a plasma and it modifies the flow along that surface. So how much does it modify it? It modifies it by up to 15 to 25% better fuel savings on a semi-truck. You can put one on the back, for example, it costs about $2,500 to install, and it will 15% of the fuel costs of a semi are from just the drag at the rear of the trailer. So you put these things on the rear and you eliminate most of that drag, you can have a 15% increase in your fuel economy just from the rear actuators. And the truck glows a nice purple at night besides. So they found a way to take a boxy shape like a truck and make it into a streamlined flow. I think this is amazing. And of course, the uses, it shows different pictures of trains and race cars and rockets and so on. Of course, jets are a big part of their business and so on. So this is very interesting. This is a whole new way of who would have thought you could use plasma to decrease the drag and all these things, and all of a sudden all these areas are opened up. And not only that, but we have plasma all over the outside of vehicles shortly, probably. I would assume all the manufacturers will figure this out very shortly. And in that way, in a sense, with the technologies we've been working with the nano-coated coils on the battery terminals and the nano-coated parts in an automobile and nano this and nano that and GANs added here and there, we're turning the car into this plasmatic operated device. And at the same time, here's normal science trying to turn the outside skin of this vehicle into a plasmatic device as well. So I think it's really cool. I think it's just part of the change of the change that we're moving toward plasma one way or another. And if you think about it, just in terms of trucks, we don't associate plasma with trucks very often, but yet they have technology such as this HHO technology, which is turning out to be more plasmatic than it is chemical or physical or anything else. It's a plasma process. The plasma of the hydrogen and the plasmas that are sparked inside an internal combustion chamber inside where all the action's happening. It's radically changed by the use of plasma. We have new plasma spark plugs, for example, that are supposedly the best and have some very good lab tests to show that they are. They're more expensive. They haven't hit the marketplace the way that the inventors thought, but that's part of what all this is about. We have the frames of trucks now are cut out with plasma. They use a plasma cutter to cut the steel. We use plasma to coat the windows. They use plasma to create the new, they use plasma now to, instead of using primer to spray paint onto a surface, you plasma treat. In fact, that's the name of the company, Plasma Treat. If you look up Plasma Treat, it's another company. You plasma treat it first, and you spray the paint directly on, water-based paint, doesn't matter what it is, it sticks like crazy to this surface, better than primer. And you don't have to pay for the primer and go through all that process and noxious solvents and terrible process. And this plasma process is safe, and it doesn't require all the ventilation and all that stuff. You just treat it, paint it, and you're done. It's a little more to it than that. It has to be particular, but still, it's just another plasma. It's all going plasma. And you'll have your little plasma TV inside your vehicle or inside your home. You've got your plasma-based processes inside the microprocessors and everything else these days. And holy cow.
Yeah. It looks like Michael found his mic.
Okay, sorry, I didn't mean to hog the old microphone there, but Michael, did you want to say something? Michael Moore, did you want to say anything? Are you okay? Your microphone's open now. You can mute it by pushing on the little mute button to the bottom left of the screen.
Okay, no problem. I'm here. I'm just observing.
Okay,
You got me?
right on. So if you need to say, you can mute for now so we don't have any background noise, and then you can unmute when you'd like to talk. That'd be
Fine.
best.
I'm just learning.
Yeah, yeah. It's a tricky thing, this Zoom. Once we get the hang of it, I think we're all going to like it better than the Skype. But Skype's gone. Skype is such a hog when it comes right down to it. Okay, it goes for Dave George as well. You can mute your microphone if you like. If you don't want to talk there, if you do want to talk, you can just open it up, and then we won't get any background noise.
All right, good evening.
Hi. Alrighty, how we doing out there? So I think I've sort of covered this. There's actually, let me just show a different picture while we're just on. Oh, my CPU usage is up for some reason. Okay, I got to be careful here. We're going to have some kind of havoc. I'm going to just bear with me a second here. Sorry, Doug. Let's see what Doug is doing here. There, I just gave him the Zoom number. Okay, just gonna check on a couple things here. Okay, now I have to go bye-bye to Skype. It's hogging too much. That's better.
Okay, just interject while you're doing that. Zork asked in the chat about some specific information about the direction of the wires around the nano pen.
Ah, good.
Yeah.
Thank you. You can clarify that while I fiddle with the background here. Sure, thank you.
And what I understood, or what I comprehended when I was looking at that, is you look from the end. My camera's not. That's okay. You look from the end that you're holding, the end of the wire with the little loop in it. If you point that away from you, the inside coil goes counterclockwise because that's the gravitational coil, and the outside coil goes clockwise because that's the magnetic coil.
John, could you share? Are you able to share there now? Would you like to do that? It'd be great to have the visual on that. It's so much better to see. Okay,
Yeah,
I'll pin
I
your
gotta,
video there now. Thanks.
I gotta get away from my microphone to be able to do that. So I'll see if I
Oh,
can do that a little bit. No worries, no worries.
it's quite a stand you have there for the mic. That's great.
Okay.
Okay, go ahead. We can, so yeah, it's a
From
little
the
video, blurry, but it's good. Okay, yeah,
end hold. Okay, one end has got a point on it. That's where the stuff comes out. On the other end, you've got the little loop to any energy that's coming down this direction gets directed back through the coils again. But if you were to hold this loop and look at it from that end, the inside coil is counterclockwise and the outside coil is clockwise. That's what I understood. Now, I may be wrong. I may have it backwards. But again, I've got 4 of them built. I just finished putting them together today. I can't take them apart and show you what's in there, but it's basically that in a smaller version that's inside these pens. And I'm going to be handing these out to a couple of energy practitioners for testing. And if they don't get any results, then I'll make some that are the other way around and try it again. But I'm so far, the stuff that I've done using that premise, where the anti-clockwise is the gravitational and the clockwise is the magnetical, looking from the source towards where the flow is going, seems to be working really, really well.
right. I think Keshe was mentioning in terms of gravitational and magnetical with the coils. And so the inner would be the way I understand it would be the gravitational, and the outer would be the magnetical. And okay, so
And in for the batteries, and if you're using this style or even the spring style of coil, you want to look at it looking down from the top when they're installed.
right. And on the
And
positive is
the positive is counterclockwise, the negative is clockwise.
right. That's the way it would.
And
And if you were to think, the way I think of it too is if you were to have one continuous coil from one terminal to the other and just cut it in half, then you have it that way. You have one, then you look at the coils from each top essentially, and you'll see one goes one way and one goes the other. But it's actually one continuous coil from one post to the other in a sense.
yeah, if you were to have it sitting on your posts and you take the flow direction here and take it around, it'll flow in. It's going to be turning the same
Right.
direction. One
Like
goes
if
one
you
goes this way, one goes this way.
right. Now if you were to take those two coils you have there and put each pointy end pointing away from each other so the two coils are pointing at each other, just hold that up. You'll see the two. Yes, now you'll see the two open ends should
Yeah.
no, sorry, it would be the other. Let me see, how would it, yeah, shouldn't
Well, the coils are identical. It's just the ends go out different sides.
I thought they would join together the two ends, but can you rotate that 180 degrees? No, then it's different. Doesn't
This
work.
way,
Just
it's
thinking,
really
how
hard to
do
see.
you get the two open ends of the coil to connect to each other?
Oh, this end here.
Yeah, they won't in that
Just
configuration.
point
You'd
that
have
towards each other. Oh, let's see. There we go. You aim them towards each other like that when you install it.
yeah. Just trying to think how that goes. It goes around.
Theoretically, you could have them on either side of a piece of cardboard. Glue them to a piece of cardboard like this, and then
That's
run
another interesting
down.
configuration, like a capacitor. That's a really interesting way to approach it as well.
Yeah.
May I show you something, guys? It's similar to what John did, but it's following the Fibonacci curve.
Okay.
Okay, let me get your. Are you on the video?
No, not yet. Let me
No,
turn
yeah.
it on. It is just a second to see what your opinion is. It's not nano-coated yet, but let me just 1 second. Can you see it here?
Let me spotlight your video so we can see. Okay, there we go. Let me make sure, just a second, make sure the live stream, okay, live stream is working, or should be good there. Okay, yep.
Yeah, it's a
Oh, yeah.
different shape following the curve of a Fibonacci.
Right.
So
Exactly, yeah,
try.
yeah. Interesting.
Yeah, one in the clockwise and the other counterclockwise. We'll see. Just a comment. Continue, guys.
Yeah, and here's another one, more of the regular, a regular coil again, which is way different than the Fibonacci. This is a regular spiral. And in this case, it was used or is used for crystal radio as an antenna. It just plugs in. And I intend to nano-coat it actually and see if that affects the reception and is able to respond better with nano-coating.
That's interesting. You know, I'm a ham radio, and I was telling Sandor some time ago that I was planning to nano-coat my antenna, so maybe I get reports from, I don't know, far away, and hopefully a good signal.
Well, if you think about what happens on the antenna when it gets nano-coated, then it might very well act to, like, basically there's nano-coatings that are similar to a fractal type structure. So essentially you have antenna and a fractal of the antenna and a fractal of that antenna and a fractal of that antenna. So you have the equivalent of a self resonating antenna. So it may be possible with just the right coating to create that. And then basically that the plasma that's created from, say, a pyramid structure on a nano coating, the plasmons, the tiny wee rotating magnetic fields that get created could act as an antenna. That they do have plasma antennas now. This is not a new concept, where they create a plasma and the plasma becomes the receiving antenna, or transmitting, in fact. And then you can control the plasma with the plasma. So you have the plasma receiving and transmitting antenna as this large plasmatic structure that's created from another plasma. And I think there's a lot to be learned there, that if we can learn those basic techniques, maybe that's the way we can create a plasmatic spaceship, which is a topic I'd like to bring up here shortly.
Yeah, but I think they use that plasma, but that plasma is the regular plasma, let's say. Because, I was reading a note that they have problems with ships entering the atmosphere, and because the plasma generated in front of the ship blocks the communication. So they found a way to use that plasma to retransmit, but very short wave, microwave.
Yeah, that's right. That's a good example. They figured out that problem of the blank time when they can't communicate with the ship when it's coming through the atmosphere and so on.
But I was thinking in this spiral, because I think that since we don't have any clue how the interface between the nano coating and the plasmatic environment flows, and following natures, it looks like the vortex takes this shape. It's a spiral with it's not very practical because these spirals open very widely.
That's right, yeah.
At least to try. But also one idea.
Go ahead, sorry.
Yeah, no, one more comment. I was thinking in design in a sense. I will let you know if I succeed or not. But I think that all of us needs a way to sense, the maybe the polarity, but mostly the relative intensity of the plasma flow, And I got the idea from this Chinese workshop. Did you see the one that has a very small container that they nano coated with a U-shaped wire, and they move it, you know,
Right.
getting close a hand or a piece of wood or something.
Yep. Yep.
Yeah, so maybe we can. I was trying to build with the needle something like, you know, a plasma intensity measurement. So we have an idea of which one of these shapes is more efficient, you know.
Right. Yeah. This is one of the devices I've started to put together recently. It didn't quite work out as I expected yet, but I'm working on it.
What's
It's it detects fields essentially, and
oh,
it has an off-on button only, and then 3 LEDs, and it'll tell whether it's a charged surface or not, or whether there's a charge in the area. So you can detect whether, you know, if you had a rotating reactor and it was giving out a field, you might be able to detect a particular charge with that. I've also got some other, you know, meters and so on to try to detect different fields and whatnot. If I hold it up to certain things, it'll tend to
did you try
react.
for example, sorry, Rick, did you try, for example, that device? If you get it close to a health pen, for example, or something like that, will it detect something? Because that's plasma, pure plasma.
Right. Well, I don't know. I don't have a health pen to, you know, to test it with
But
necessarily.
I think that the other experiment you did with the plasma ball and all the reactors, I think this detector will detect that, because, you know, in the interface, in the Coulomb barrier, there is like a, how do you say, an interaction between fields, and, you
That's
know,
right.
they create a lower frequency, like leftovers, and
That's right.
they fall in the.
I've proven that concept with the plasma ball. I showed it in a previous workshop, doing a reading with this instrument from around a plasma ball. And if this, as an example, if this was where the plasma ball is, and this is where the instrument is, then all around the plasma ball at a distance of about 1 meter, there was a field, a very distinct field that when you get closer, the field decreases, and when you go further away from that point, it decreases. But right at the certain point, 1 meter away, was this really big reading, and all the way around or above the plasma ball sphere. So it made me
Yeah, that was
realize,
very interesting. I saw it.
yeah, so it's like a combination of fields that creates, like you say, a Coulomb barrier around that particular object. And it makes me think, well, it's the same with all rotating objects. We'll have some sort of Coulomb barrier that will probably start to extend beyond their actual physicality. So whether that's close by or further out, and whether you can measure it with this kind of instrument, that's another thing. This is for electromagnetic fields. And oh, I'm sorry, my microphone seems to have gone off here on live stream. Thank you, Guy, for letting me know about that. Like, sorry about that on live stream. I've been yakking away, but not talking. Any case, we're talking about this electromagnetic detector and how it can detect the fields of a plasma ball, standard, 8-inch plasma ball, from about 1 meter away, and that these fields seem to be just at that point. They're not closer or further away, just at that 1 meter Coulomb barrier. And sorry, you were going to talk a bit more about that.
About what?
Annabelle, did you say something else about that? I think I'm going to cut you off there.
No. I was saying I saw that workshop. That was a very, very interesting experience, because the field was very, very sharp. You know, when you move it, I remember you move it inside and just fall down,
That's
and
right.
outside
Yeah.
the same thing. It was very evident.
very distinct field. That's right.
Yeah.
So in the sense of what you had before there, like if you look at this diagram, this is the Tesla bifilar coil, the patent that Tesla had. You can see all the coils, of course, are very tightly wound. This is double wound bifilar, so there's actually two wires that wound together, sort of, and connected in a very special way. Got a moth here that's really interested in it. Come on up and have a look. Get off that battery because you might fry yourself if you sit between the terminals on the other side. Anyways, this is different than the coil you had, which is the open-ended coil. And I was struck by when I saw your open-ended coil about it just seemed to be receptive. It seemed to be like wide open to the universe, you might say, to the energies of the universe. This is all more concentrated and more focused on itself in a way. This might be able to concentrate the energies better in a certain way, but yours seems to be a really good way to collect them or to send off energies out into the universe rather than focusing them in one area like this sort of seems to. Anyway, it's just a visual impression I got when I first saw that open-ended coil.
Did you already did it that coil, or is a project?
I've done it, yeah, I've built this with wire and tried to use it a bit. It really depends on what frequencies you run through. It works good as electromagnetically. You can put a ball in the center, put a ball on the edge, and then power it, and it'll pull it right into the center. And with certain tricks, you can get things to rotate and various other things. I don't know if it's actually designed that way. Tesla said that it had very special properties of which he didn't want to discuss in the patent. And yeah, I've also, thanks Guy for all the props here. I got this one, which is a coil that I created out of tubing. This is tubing normally used in outboard motors and that sort of thing. And it's wound bifilar, so it's similar to the Tesla coil in the way it's wound. I had it very exact to the diagram at one point. I actually had this underneath and everything was just the same and so on. But then I ended up messing up something and I had to reconnect connections and it kind of got messed up. But it does the same effect as the bifilar coil in that it's quite interesting the way the flow goes. It goes, depending if you start at the middle or start at the outer edge, but it goes toward the middle and then comes back around and comes from the middle to the outside again. Or contrarily, you could have it set up so it goes into the middle to the outside, back to the middle again, and then to the outside. So each one of these are alternating. It's got the flow goes one way, next one the other way, next one this way, next one the other way, and so on. So they're conflicting abrasion sort of orientated flows. They're going to flow against each other. And if you have GANs
So
and errors, go ahead. Sorry.
It's like a gravitation. You will get some gravitational effect because they are flowing in different directions, right? Or
right.
Are you gonna run GANs on it, liquid GANs, or?
Yeah, that's the idea. I tried salt water just to see how it might react and see if it got some sort of magnetic field from it. So far, there's also GANs and so on. I want to try with it. It's actually got a little it's hard to see here, hydrofloss device here that it's hooked up to. Normally you use it to sort of brush your teeth with high velocity water pressure. And so it's actually, it does work. It's quite amazing. And with this whole device, just to gear this up a little bit here, with this hydrofloss down a little bit device, you can control the flow with the this switch here, the pressure like, and you can also fill this container up with, you can put GANs, you can put other nanomaterials in, you can control the pH of this and so on. And it's got all these nifty little nozzles that comes with the whole device for different pressures or different other ways you could use this whole thing too. So I'm just experimenting with that. Yeah, it's got me wanting to buy one for my teeth now too, because I want to actually experiment with regrowing teeth, and part of that experiment involves using nanomaterials and electricity and pressurized water. Yeah, it turns out you can actually grow teeth back with, you can, first of all, you can take out the tooth decay. You can actually remove tooth decay with a certain solution plus using electricity, low voltage. And within 5 or 10 minutes, you can actually remove the tooth decay. And
Rick, are you talking about putting some electricity in your mouth?
yes. And then you can rebuild your teeth using a similar technology. And you can also, there's other techniques as well, naturally without using electricity and so on as well, but using nanomaterials. It's all about creating the environment. If this was your tooth, for example, and it's trying to grow, well, you have to create the right environment around it and inside of it. That's the whole trick about it. It's
but you're talking about a teeth that is still there, or
pardon me, say again.
no? Are you talking about a teeth that still is there,
I'm
or
talking about
brand new one?
I'm talking about, let's say you have this is a tooth, but it's all black and decayed, has a big hole in the side of it. I'm talking about it's possible to remove that decay and regrow that tooth.
Oh, interesting.
And you'll see in tomorrow's workshop, the Knowledge Seekers Workshop, 75th Knowledge Seekers Workshop, Yvonne, well, as long as Mr. Keshe okays it, I hope he's going to okay it. I haven't heard back yet. Yvonne has a presentation about regrowing teeth that he's going to give. Yvonne's a dentist.
Since you're talking about health stuff, I remember, I'm telling you because I'm wrong, but Mr. Keshe said after the presentation of the Philippines of the health pen that you can use it for several applications, also Alzheimer's. Because I have a neighbor, she's a lady in the 70s, and she's, I feel so sorry because, as you know, there is no cure and no interest in curing anything like that. And,
for what again? What was the illness? Alzheimer's? Okay.
Alzheimer's, yeah. So I was thinking after, what you say? Yeah, well, the fact is that after testing on myself or friends, this stuff, I was thinking to make a hat, of course, with all the precautions of the guns, the tips of the health pens, isolated very well to create like a hat and something. I was thinking putting something, let's say, magnetical configured over the head or close the head, the brain, let's say, outside of course, but close to, and another gravitational on the field. So letting the flow of the fields, inside the body from one end to the other. I will ask, I don't know, I'm just sharing with you the idea because it's all about trying to help, right?
Well,
so I'm not
it's
sure.
funny. We do have Michael here. He could definitely speak to that. He's a hatter. He makes hats, believe it or not. And he's been Michael Moore.
Oh, okay.
And part of what Michael's done is he's I don't know if I've lost my control here.
I'm here.
Oh, hi, Michael. How you doing? He's created hats, and he's created hats with a pyramid structure, for example. So you wear the pyramid hat, and it has certain effects. And then he's also creating or will create nano-coated wires inside the lining of the hat. So it will be for special purposes for people. You can imagine that that could be very interesting. So you won't have the direct contact of the nanomaterials. You'll have the fields will be available and pretty much directly available where they're probably needed, close to your brain. You know, you have to be careful with that kind
Well,
of
but
technology. But still.
Exactly, that was the point, because these guys at Philippines, they were talking about using the hands on the feet on the acupuncture points if you want to access something, above the neck. So that's why I was in doubt, to use this system directly on top of the head or on top of the
Yeah,
brain,
I
even not
wouldn't.
touching anything or getting any close, like 1 centimeter, half inch, of the head. But I'm not sure.
Yeah, there's some question to that. Definitely with needles, you don't be, messing with things that way, and nano-coated needles are not something that should be used on humans anyway to start with, or animals. But that's a whole other topic in a way. We're told so far that nano-coated materials shouldn't be touching the skin so much, or especially GANs on or shouldn't be ingested, especially. That's sort of some of the general guide rules. I'm not sure if we've had guidance in terms of nano-coated materials and how close they can actually come. This is an interesting concept, or how close they need to be. This is what I was trying to get to a little closer with John earlier too, with his pen, and see how
Well, I
close that nano-coated tip was to the actual skin, and what's considered, okay, normal, or too close, too far, and so on.
well, Mr. Keshe was talking about the length of the health pen in relation with the distance between the skin and the organ you want to reach. That's a measure of the energy, the length of the pen, because it will collect more or less energy depending on the size, length. So I think that brings an idea how far it should be from the brain, because it's very close to the skull, so maybe an inch far away from that. The only problem is that there is no way to test. Everything is in development. There is no history. There is no reference. That's a different part.
Somewhat, yes, somewhat. Although when you look at like Shandor's pictures that he posted of the prehistoric spirals jewelry, and you think, wow, they throw that in the fire. They have it nano-coated, and they've got nano-coated copper spirals, dual spirals, one way, one the other way, back in prehistoric times. And you better believe they spent a lot of energy to make them, because they don't just find raw copper out, laying around on the beach or whatever, like you do gold. You have to actually melt it down and use some chemicals and transform it from its oxide into the raw copper and all this, and then start working it and making it into jewelry, and knowing that that spiral was somehow associated with some of the inner, workings of the universe, basically, all from a prehistoric point of view. So maybe it's possible to do this technology without knowing, even consciously sometimes, but certainly without knowing the exactitudes. Like if, as long as you know the next step, you know enough to carry on. And if you know your heart well, maybe that's enough for connecting where the knowledge is to be able to do it as well. As Michael mentioned, he's come up with like so many beautiful things on his Facebook site. We should pull up that link maybe, but on his Facebook site, he's just posted so many beautiful copper wire wound items. And if you talk to him, he'll probably say, I don't know what they do and I don't know why I make them, but here they are. And they have all the reflection of the universe in them, in the sense of they look like they're going to work. Basically, to me, they have a sense of correctness about them that only comes when you're tuned into that space of feeling the things that you're making, basically. And then if you put the right intent into it at the same time as you're creating this and feeling it, then if it feels right, it will be right. And it'll be likely have a good effect with others, or others will, feel good from it, the use of it, and so on.
Talking about intent, do you know if John have any update in the flying bike? Hey, John.
Well, I've put the coils on my bike. Put about I'd say about 30 minutes on it. There was some really subjective things that happened. I can't replicate them. I can't even really discuss them because it's just a feeling that I got. But one thing I did notice was that since I put them on, every time I've gone out, I've averaged 2 gears higher without getting any more tired than I used to.
Oh,
Well, that's an interesting one, that's for sure.
I used to cruise at about 15 to 18 kilometers an hour. Now I cruise somewhere between 18 and 20.
Huh.
well, it takes time.
Yes, but I also think I screwed up because I didn't nano coat the tubes that I put my GANs in, and I think I've got the wrong GANs. I'm having a hell of a time coming up with what I'm confident is CO2 GANs. I think the vast majority of what I've created has been zinc oxide.
Well,
And
that's a good point. That seems like a pretty, it's a delicate area. That's exactly right. It's hard to tell what the difference is there, I think, and we need more tests to confirm. Maybe it's a good question for a workshop.
yeah.
What are you showing, Rick? What's that?
I think this is likely Shandor that's sharing this. I can't tell here off the bat, but it looks like the same pictures that he
Jamie
shared.
Welch's screen.
Pardon me?
That's Jamie's screen.
Oh, is it? Okay. Thanks, Jamie. I can see that quite well there. This, I believe, was the prehistoric jewelry, was it not? You'll have to unmute yourself, Jamie, if you want to talk. I'm not sure if you're trying to talk there, but your mute button's on. Or you can comment in the chat.
Well, I know his mic works because I talk to him almost every day. So
Yeah, I've heard him before, but it's off right now, and I can't change that myself here. So,
well, you're the host.
well, I'm supposed to be the host, but something's going on. It won't allow me to change it. So,
No, I'm the host.
I thought somebody was back there that changed something.
I seen you were busy and there was other people's video on, so I just took over host and started stopping people's video.
This is Vince, right?
Thank you.
Who needed to be unmuted, Rick?
It was, I'm unmuted. It was, I couldn't find the screen to get to the button.
Right. Yes.
Yeah, that was a picture that Shandor shared with me. It's one of, he's got quite a few here somewhere. I believe they're relics from Hungary.
Hungary. Really
I believe that's what he told me.
interesting. All right. What else we got here to show and tell?
May I ask a basic question?
Of course.
Well, why in the CO2 kit we just nano coat one sheet, the copper sheet, and not the zinc one?
Why you nano coat the what? Sorry.
One of the sheets only. The we nano coat just the copper one, not the zinc. Is there any reason for that? Or, because why we didn't coat the zinc too? I mean, what's the effect of not nano coating or nano coating one of those sheets? Maybe it's a
Well, I find that the
stuff,
zinc. I find the zinc gets coated one way or another anyway. It doesn't stay shiny zinc. In fact, it eats away and is goners after a while. Big holes in the side. So I don't know if the nano coating would make a difference in the zinc sides. It's like I said, I think it's sort of self nano coats and takes care of itself that way. But a part of it is the idea of potential between the two plates. They're different magnetic gravitational fields, and so you could have copper and copper oxide, or you can have copper and zinc, copper and zinc oxide, copper oxide and zinc, copper oxide and zinc oxide, and so different combinations will produce different effects. But when you connect them together with a nano-coated wire, as we do, then you're automatically suggesting the conditions for that particular offspring that you're making. So as in making a battery or making any other kind of electrolytic situation, it depends on your two materials. They have different um, potentials. Their electrochemical potential, just as an example, will be different. So in other words, there's set values for copper, there's a set value for zinc, and if you use those two in salt solution or whatever, you'll get a certain battery effect take place. It'll either be able to charge it or discharge it according to like batteries electrodes operate and so on. Or if
yeah,
you do
but
electrolysis, for example, if you do electrolysis, which is almost an electrolysis process that we're doing, but it's more like colloids or whatever, it's GANs, and that's its own thing. Then the nano coating will make a difference in the same as it would in electrolysis. And if you have a certain electrode, the electrode could get fouled up, and then all of a sudden you're starting to produce a different coating than you thought you were. And if you start plating things out, then certain things will plate out of your solution if they're in there according to their electrical potentials. First one, then the other, then the next. And that gets back into whether you're creating the GANs of CO2 or are you creating the GANs of the zinc oxide. Well, one will tend to come out of solution or go into solution, however you like to look at it. It manifests itself usually before the other one. It'd be like a fine line there between the two. And generally we seem to get both, and it's hard to tell what is what. If you start to rotate them in a reactor, then you can see the division. There'll be lighter stuff and a heavier stuff that forms out in those rings, in the GANs rings inside the reactor, inside a clear reactor, so you can see it. So then you know, okay, there's the two layers there. There's two definite densities, two different types of material. But there could be dozens. There could be dozens of types of material that still look white and fluffy. That's the whole thing about it too. Hopefully, we hope and expect that if we follow certain processes, and we're told by, you know, Mr. Keshe that this is what we call the CO2, which he also says not necessarily exactly CO2 as a CO2 from the atmosphere as one little CO2 thing. It could be CO2 or CO3 attached to this other molecule as a hybrid kind of thing, and so on. And there's a lot going on in that process. There's many things being
By
created.
the way, in the connections, in the connection, Rick, I heard Mr. Keshe saying that you know, it's a good idea to use a nano-coated wire between the plates, not the regular just copper.
Right.
That's what the comment. So it will be an improvement, because I think that a nano-coating process will prevent the regular reaction, chemical reaction. Since
Well, that's a good point. I think that's a really good point. And I think it's sort of like bypassing the ordinary reactions and only allowing a certain type of plasmatic reaction to take place. And that's all about the conditions again, to create the conditions where those chemical things don't want to take place because other things are taking place that are more important to it at the time.
So maybe if I nano-coat the thin plate, it will work the same way, maybe also better. Nano-coating ball. I will try that stuff.
It would be a good experiment to try and see what materials you get either way, and if it's created, materials are created faster or slower, and so on.
Exactly. So the CO2 is always coming from the atmosphere. If we seal the container of the CO2 kit, it won't work, right?
Well, that's a good question too. I wondered about that because if you think about it, there's lots of carbon in the walls of the container. It could easily leach it out, pull it. The fluid could pull that out from the container itself. The plastics of the container would have carbon. The O from the oxygen will be in the atmosphere definitely for at least a short period of time until it gets absorbed by the salt solution and the electrodes and so on. It'll tend to pull that out. So what happens then after you don't have the oxygen from the air, you don't have say you don't have it from the walls of the container, although there should be oxygen in there too, I suppose. But then you have the water. So you have your H2O. So does that mean the water starts to get broken down to provide the oxygen for the process?
But my question is, you know, since we are in the universe, even on Earth, you know, my question was related with where, because there is a soup of magnetic fields, right, all around us. You know, if we tune certain plasmatic magnetic fields, it will attract it anyway, even if they are not present in a matter level. That's the question. That's why I'm asking if the steel container will anyway extract from the, let's say, vacuum or whatever we want to call it, and extract it from there, even if there is no matter around.
So could you explain a little bit again about what would extract from the fields that are ambient and around?
Yeah, the idea
reactor?
is that the reaction of the magnetic gravitational fields and the conditions present in the CO2 kit is like a magnet, right? That will collect certain molecules, CO2 molecules. And if they are not present in the environment, on the surface or, below the surface of the water, still there are, the soup of magnetic fields of the universe present in there. So,
Oh, I see what you're saying.
maybe
Yeah,
it
well, there's a soup.
dies.
There's a soup available, but I think I think the situation probably usually feeds on what's available rather than the cosmic soup, in the sense that if there happens to be zinc available, zinc oxide, and some lead oxide or some other oxide, it'll tend to convert those to the GANs, whatever is next in line, basically, magnetically, gravitationally speaking. In other words, you get the lightest thing or heaviest, depending on how your arrangements are set up, or one substance will precipitate out, so you'll get your CO2 GANs. Then you continue with the experiment and you might get the zinc oxide GANs, but before both of those you might get a calcium GANs or a calcium carbonate GANs if you have calcium in your water to start with. Say you use tap water and it's high in calcium, and all of a sudden, bingo, you've got this white precipitate. You might think it's CO2 GANs, you might think it's zinc oxide, but it's likely calcium. But once that comes out of the water, then your next in line's ready to go. It's almost like back to distilled water then. So then you'll have your CO2 reaction could take place, or the zinc oxide, depending on the exact circumstances, which could depend on the exact pH of the water, could depend on the temperature, could depend on the atmosphere and how that's reacting. And especially especially what makes a huge difference will be the potential between the plates. And like you say, if you use nano-coated wire, that's going to be one potential. If you use bare copper wire, that'll be a totally different potential. And if you use nano-coated plate versus not nano-coated, then that'll make a difference. If the plates get nano-coated naturally over time, then that'll affect the equation. That'll affect the way it plates out and the way the GANs gets created.
Yeah.
So there's many.
Another point is the way you attach the copper, because if you attach copper that is already nano-coated, the surface is touching nano-coated on nano-coated. You understand what I mean?
Yes,
Once
exactly.
you attach a cable. And another thing, I was thinking also before nano-coating, do you know the spot, they call it spot solders, like a dot, they hit just a point and solder metal to metal in just one point. They call it, I think, spot solders or something like that. It's not with lead or tin or something. It has nothing to do with that.
Okay.
Just is with electricity. You join two metals and touch them with a high current, and it will fuse one onto the other. So copper on copper, and copper on zinc, and then nano-coat the whole stuff together. I will try to do it that way. So it's a whole unit.
Right. Well, that's another idea.
Yeah. I'm just asking because maybe somebody did it already.
Right. I'm not getting anybody popping up about that, but that's what we're here for, is try to figure out. Hello?
I was discussing with Shandor the other day the possibility of using borax and possibly a hot torch to fuse copper with copper. Was Shandor's idea.
Yeah. You can do that. It just takes very high temperatures.
Yeah, I don't think I have a torch here available. Maybe I can play with my arc welder and try to get something to stick.
Well, you can't do it because the problem is that the nano coating comes off when you heat it. So You can't
No,
can't weld the
before nano-coating.
Yeah, before nano-coating.
Oh, to attach what to what again?
Like to make a copper ring to attach the two ends together and then nano-coat the whole thing.
Oh, I see what you're saying. Yeah. Yeah, you could do well, you could either do a high temperature brazing, but you could actually do copper to copper. That is possible to weld it together. It's just very tricky. It tends to melt, and as soon as it melts, it drifts. It's like you can weld gold together too. I tried it with for the first time. Somebody's microphone makes a lot of noise. I tried it for the first time with to weld gold to gold with a broken ring. My grandfather's heirloom ring that he gave me, his ruby ring that I inherited, but it was broken so I tried to weld it back together with my oxyacetylene torch. And instead of welding it back together, I just melted both ends that were broken, and then it had about a half-inch gap between the two ends instead of the little break that was in between. So it all happens pretty quick in the melting range. But yes, copper can be worked with that way. You can also beat it together, heat it. Go ahead, sorry.
Did you see the coin batteries, the small batteries, the coin ones? You know
What
what I
about
mean?
them? Yeah, what about them?
Well, they have the contact. It's soldered there without any tin or lead or whatever. It's just a dot. Just they solder it with a. It's not an arc. It's just a flow, a high current for a second or two, and it will melt only that point and join metals together. I think it will work with copper.
Yep, it'll work. And the idea of the borax is to keep the oxygen out, because as soon as it oxidizes, you can't get the surfaces to connect. It's the whole thing about the oxidation process. And copper is soon, in fact, any metal, as soon as it's made bare and clean, it starts oxidizing immediately. Some of them look clean for quite a while, but they're still oxidizing.
Yeah. I'm looking for these machines to show you.
Yeah, it's called spot welding is what it's actually the term for it. And for Jamie, your welder might produce enough current to be able to do that.
Yep, you can spot welding. Something I did on the assembly line of General Motors.
Now they do it with robots.
40 years ago.
There is an echo.
There's an echo. That's right. It's okay now, I think.
Yeah.
Yeah. Okay, well, what else is interesting? Still working on my little reactor here. I don't know why this isn't focusing. Hello. Maybe it's just not enough bandwidth or something. I don't understand. It should be more clear. In any case,
I see you very well.
Is that a toy drone?
yeah, this is a little. How come there's an echo? Does someone have their live stream open, or what's going on here? Hello. Okay, it's good now. Oh, get inside this frame. Yeah, this is a little drone I've attached. Actually, it's pressed on. This is a tiny little glass sphere, and it's glued onto a metal bottom here, which normally has a little screw cap that goes in the end. I took the screw cap out and screwed in one of the plastic hubs from this screwed in one of the plastic hubs from this little drone here. And now it all just fits on there quite nicely. It's not perfect, but it probably can be with a little bit of finagling. And it comes with a cool little thing here. I'm not sure if it's charged up that I can actually show it, but you can hold it there. And we'll see if it actually works. I'm not sure if it's gonna. Oh, there it goes. You see that going around there? See the little sphere going around, right?
So you got a plasma drone now.
Yes, exactly. I'm going to put 4 of these spheres on with a little bit of the right nanomaterials inside. I'm not
It's a
sure
very
if
good,
I'm going to use GANs or just with nanomaterials in this case. And it's going to be very simple. Like I'll be able to just pop this off, use a needle in here to extract or put in GANs or gases or whatever I want. And it'll still have the little hole there, but I just stick it back on and it's sealed. And as long as
What's that?
everybody,
A lamp? What is that, Rick?
which
Lamp?
this here,
The ball.
the
Yeah.
ball is actually, it comes with as a sort of an amulet thing. It's a for beads and amulets and that kind of thing. You normally might put in some seeds or other things that are special to you, and you hang this on a chain from your neck. I've actually got some like that that I've made up as a GAN's bead necklace. And ultimately, I'd like to be able to have a drone like this that you take your bead necklace off, stick it on the drone, and essentially charge it up by spinning it. And this little baby will spin well over 10,000 RPM when it gets going, so it can definitely spin things up. And with 4 of them all spinning together, it could be quite an interesting thing. And definitely, if you get lift, it'll let you know. It moves around. Let it sit there for a second. So I can actually, with 4 of them, I'll actually be able to control the way it moves around a little bit.
Well, as long as you don't cheat using a propeller in one of those, we can't believe it flies.
Yeah, right. I've tried it with a couple of propellers, and it just goes, falls over on its end. But even when it's on its end, with at least with the sphere, I've actually been able to make this thing run across the floor really quick. You can control it. So yeah, it's amazing actually.
Yeah, it's a very good idea. Simple.
Yeah, it's very interesting, and it's actually quite cheap. The drones now are less than $20 for these guys. They're quite incredible with the blades on them. They can do a somersault in the air. You just push a little button and it turns a somersault. They can fly for 5 minutes. You can run them indoors or outdoors and do tricks, and they're quite precise once you get them lined up. They can hover from take off and land on your palm basically. And yeah, it goes up and it automatically does a somersault. I haven't gotten to that point yet because I broke the propellers before I got a chance.
How long the battery lasts?
About 5 or 6 minutes, something like that. Just pretty good for 4 little motors just screaming away.
Yeah.
Quite powerful.
And it's got a really good GPS system and so on. Yeah, the motors are quite powerful. I was surprised it's able to turn the sphere so quickly and easily. It gets right up to speed immediately. Like, takes a while to run down. It's amazing, actually. It's like right there. So the trouble is to try to run it with the spheres on for a long period of time, you know, with a battery connection and so on. It's going to have issues because it'll probably overheat the little motors and so on. They're made to run for a short period of time. If you were to have this on full throttle, it just goes immediately out of sight. So
Can you not cold put it in a cold environment where the motors are kept cooler?
that's an idea, Guy. It could be in a cool environment of some sort. I actually, where's that sphere, glass sphere thing that was just here? Yeah, the one right in front of you there, the glass one, the sphere, that one, in its base. Guy was wondering last week why this. I have this. Guy brought this glass sphere, beautiful little thing he found in the thrift store, didn't you? And it unscrews actually. It's got nice screw threads, nice base. We're gonna put some kind of motor or something in here and a rotating reactor inside. But last week I was messing around with this little guy when it had its blades on there. And I actually put it inside of here, screwed the base on, and I could actually fly it with the remote control. You can see it there now. And I could have it hovering inside. It was really cool, but it was whacking. The blades were whacking on the inside of this. And it's marked it all up inside. They'll be easy to remove. It's just plastic. It's not actually scratching the glass. It actually is little plastic marks that have been left on the inside. But it's an interesting concept. If you could just have a little hovering drone inside of this, glass sort of magic sphere here, I think that would be so cool. It's pretty cool just having the drone hovering in there itself. But having the drone hover when it only has glass globes inside of a glass sphere, that would be really cool, I think. So we shall see. It's nice having the glass sphere, so if the glass globe comes apart and goes flying, it's not going to break this. This is really heavy glass, and it'll be able to take the punch and not poke your eye out.
Oh, we can put a polycarbonate tubing.
We can put polycarbonate tubing around the whole thing too, if we wish, and so on. But I like the glass globe. It's nice and compact. You can just put it anywhere. So lots of fun things happening in the lab here occasionally. It's just we don't have enough time to follow through. There's too much crap going on in the world, and having to do videos and all the teaching and putting up with all the bullshit that goes down and so on. Time consuming.
By the way, I have one more question about sharing or asking if somebody already did it, but I was thinking to, after returning to the nano-coating process, the second stage, which is drying the sheet nano-coated. Do you think that under vacuum conditions, because they already have a vacuum since at the beginning, remember Mr. Keshe was teaching using gases and vacuum and all the stuff. So I purchased at that time it doesn't go too low, but it's a good one. It's high vacuum pump. It's not the molecular, but it's the first stage. They call it backup pump. And I have a chamber. I also got a chamber. It's a polycarbonate chamber, which is huge, like in diameter, like 30 inches in diameter. It's in a sphere. And
30 inches?
Yeah.
30-inch sphere. How thick is it? Is it quite thick?
Well, yeah, it's designed for that. I asked the manufacturer how low it can go, and he said it can go full vacuum. I don't know what it means full vacuum, but it's strong. It's very strong for the shape, and it's reinforced, and it has a seal made of whatever, but it works. Anyway, I don't go more than 10 rice, maybe 3 or 4. But my idea was to help dry and build the crystals of the shapes of the surface of the nano-coating, which is critical. Because I think that everything is relating from the process of nano-coating. It's more, I think it's the most critical part of all this. How to let the crystals or the shapes in the surface to grow properly. And maybe under lower pressure, and I can get two benefits. One is releasing the atmosphere pressure, so it will build the crystal maybe, I don't know, I think so, faster. Another effect is all the water will blow up from there. You know, it will extract all the water. Actually, these chambers are used to dehydrate things.
Right. So the water will, you'll have to get the water off before going below about a, whatever it is, 1,000 torr or something like that, I think. Or at least, let me see, how does it go? At least 1,000 microns. I think about 1,000 microns when the water evaporates, or before that. So all the water will boil off before you'll be able to take it down to a lower vacuum than that, essentially. So that could be a great way to get rid of the water, if water is a problem. And it can be a great way to create the atmosphere that you want to create inside of the sphere, or whatever it is.
Yeah,
so,
they call it dehydration chamber. Yeah, I got it on eBay, very cheap. I bought it used because it's very expensive, a brand new one, but it's perfect. Have no issues. So, but I'm just sharing ideas because I can hear objections or
so how would you create the coating when it tends to evaporate? Any of the vapor or liquids that would tend to evaporate?
No, I will let it dry. You know, at least for a couple of hours or more, maybe, I don't know, because Armin was saying that it was 24 hours to dry, at least. And well, maybe after drying it a little bit, I will put it in the chamber. So releasing the pressure, the atmospheric pressure, the water will boil, will be sucked in from that plate, and at the same time, all the part of the nano coating that is not needed, maybe it will be out gas. You know, it will be released too. So maybe I'm just speculating. I'm not sure. I will tell you when I do it. But all the parts
that sounds interesting. All right.
Yeah, all the parts that that is not uniform or is loosened in the surface will come out also.
Well, they do use processes like that sometimes, depending, and of course they've got nano-coating processes using gases to do like the carbon diamond-like coating. That could be done in a vacuum or partial vacuum condition, and then using voltages to force the material onto the substrate, they call it, or in this case, if you had copper as the substrate, you got your copper, and then it's all in a vacuum. You're in a vacuum condition, and say the copper is, I think it would be negatively charged, and then you might have some gas that comes out of here, such as acetylene. They pump acetylene out, and this could be charged positive. Let's say this electrode, acetylene comes out and shoots onto the copper surface, and under the right conditions, that'll form a diamond-like coating on the surface of the copper, a few atoms thick. And it doesn't take long; it just goes psh, and it's done. It's a few seconds.
Deposition. They call it deposition, right?
Pardon me. Electrode deposition. Yeah, there's deposition, and in the case of using gas, usually with deposition, it'll be more. Oh, you can have gases. You can also have solids. They'll heat up. you know, I don't know, titanium or not titanium, but some other material. It could be gold. They can heat gold, and it'll deposit on the surface as a mercury, depending on what you're coating with, and it'll almost instantly coat that surface with between the voltage charge and the vaporization of the material with heat, a little heated electrode, for example, inside the vacuum chamber can make the material evaporate and instantly coat a glass slide or a lens or something like that. But the acetylene is interesting, or which is, I think it's what, C2H4, what acetylene is, or C2H6 maybe. So it's basically carbon and hydrogen. So when you have it in a vacuum, it doesn't burn, even though you have high voltage going on. It creates a plasma, and that plasma coats the surface with carbon in a way that's just a few atoms thick, but totally changes that surface. If it was steel that would normally corrode, then it would have a nice shiny surface and it wouldn't corrode. Just from a few atoms. Eh? So
Yeah, well, that's another issue. You know, why we need to get the surface totally dark black? Because even if you can see the surface of the copper, maybe it has thousands of layers of coating already. It won't be enough, or what's the limit? I mean, where you stop? Because you can do the process 2 or 3 times. Once you're done, start all over and get more layers and more layers.
well, that's the question, all right. Is more better, and how much, and so on.
Exactly.
So one question that would come up for designing all this is, what do you want to do with your thingy once it's coated? What is your specific goal in mind? How is it going to get used? Is it going to get used with nanomaterials? Is it going to get used with gases? Is it a combination of both? Is it GANs? What's going to be next to this nano-coated skin that you've created? What is it you're trying to protect from, or you know, have either absorb or repel from that surface? And you can go either way with it, you know, like the way I look at it.
My thinking is that more layers means more capacity to let the plasma flow, right? You have more layers, it can expand more and let more plasma flow between those layers. So the density of the plasma will be much more if you got more layers. I think, I'm not sure.
So what you're saying is that, for example, if this is the sphere and you have a nano-coated all these layers inside the sphere, let's say, that the more layers would be better in terms of the plasma that's found inside the layers, you're saying, right? Basically.
Yeah, exactly. Yeah, because more layers mean more gaps, more let's say more room for the plasma to flow.
Okay, so if we had a reactor that was all layers right to the middle, would that be best?
All layers inside?
Like, what if it was all layers and maybe only had either a tiny weak core of nothing in the middle, or it was maybe even not have that. It's just all layers all through it. Would that be the most powerful
around it, you mean?
environment? All of these layers would be inside the sphere.
No hollowness.
No hollowness inside, just all layers inside.
But you mean it's solid, so will be like solid?
Well, the layers aren't solid. That's, you just said there's holes and gaps, and that's part of the layer. So in a sense, it's solid, but it would be just the layers, which with holes, gaps, and so on involved all the way to the center of this sphere. Would that make it more powerful, I'm wondering? Because
Yeah, it's a question I think we need to ask Mr. Keshe. I'm not
it's
sure,
a tricky thing. I think it would depend a lot on the actual how the layers were made and so on. Like you can imagine, for example, with say we had a substrate. Let's call it copper. And this is copper. All down here is copper. Okay, so then we have this thin layer of, say, if it was, for example, graphene. If you had a layer of graphene laid on there, it turns out the properties are better with graphene if it's on a thin layer. The thinner the layer, the better. In fact, any more than just a few layers of graphene screws up its qualities. So in that sense, more layers doesn't make it better in that particular case. On the other hand, if you were I think if you were, for example, protecting the inside of a nuclear reactor, then you'd want lots of layers to act in case when a incident radiation particle comes in and knocks off some of this nanomaterial, it goes shooting off or whatever, then you want it to be able to heal itself. Essentially, you don't want it to get down to your bare copper, because then you're going to be exposing the plasma to of this reactor to the bare copper, and that's not a good thing. You want to keep a plasmatic layer between the plasma and the physicality matter material. So in that sense, many layers would probably be better. And from what I read is that they do use copper oxide in nuclear reactors as a lining material. And why they do it is they like the idea that it's self-healing. If a chunk of this gets knocked off, then the coating takes care of itself. It naturally repairs the layers where there's something missing. And we've noticed that when you create your nano wire, the coating will usually continue crawling up the wire. We've got wire with insulation over it that it's crawled right inside the insulation and gone right up the wire, basically. And that's the way this stuff works. It tends to spread out when it has a chance and is in the right environment. So
you mean the nano coating we are doing try to dissolve, or are you talking about that?
Not that it tries to, it'll try to repair itself more than anything else, I think. So that on the inside of a reactor, if there's a little bare spot among the rest of the reactors all coated, then that bare spot will tend to, it'll tend to self-repair over time. It'll tend to start coating itself just due to the surrounding nano coating. And that goes for any little spots that might be nicks and cracks and things that are missing. So I think that's where the thicker coating might be even better. It'll be more self-repairing and so on. Maybe it's important to have a certain thick coating. I think it really depends on, excuse me, what are you using your reactor for? What is the end result? What is this substance out here? Is this some big high temperature plasma? Is this a really strong magnetic field like this, 129 Tesla magnetic field that should be tried to be bounced off this nano coating layer here?
No, we are talking about collecting energy from the environment, plasmatic energy from the environment. That's the main purpose, right?
said that, actually, right? Tell him mommy says
All natural.
Whose phone is on here?
So,
Oh, we have Mayran's iPhone. Maybe that's where we.
that's the perfect time to ask. Just in time.
That was me, but I just came on, so.
Oh, he's gone away again there, I guess. We found him and he disappeared. Hard guy to get a hold of. But he always shows up at the right time.
But it will be a good question because now everything, as you can see, as we can see, you know, is almost went down to the nano-coating and shaping. The shapes and nano-coating is all about. It's most well, of course, the guns you as a source of energy, but you know, it has changed everything. These shaping, spirals.
What would be the question then, the exact question to formulate?
The question will be if nano-coating, if the width of the nano-coating is important. If making the nano-coating 3 times will be better to have only one nano-coating, regular nano-coating. It will improve, you know, improve the collection of energy from the environment.
So, sort of like how important is the thickness of the nano-coating to pick up energy from the environment?
Correct, that's the idea. We are ready to.
So it's how important is the thickness of the nano-coating to absorb energies from the environment?
Yeah, and if we can ask if the, you know, drying the nano-coating in a vacuum environment would be useful or not.
Is drying useful again?
Drying the nano-coating on vacuum will be useful to get rid of water and leftovers of the process.
Right, thank you. And again, we have to maybe clarify somewhat useful for what in particular and in what particular, and even with the thickness of the nano-coating to absorb energies, it might depend on what kind of setup you have. Maybe it's more important to have nano-coating on the outside of a sphere than the inside in certain circumstances and so on. It might depend on that. But it's a good general question, I think.
Interesting, yeah. Yeah, because I have it, my idea only, you know, as far as I know, the nano-coating is preventing, for example, the plasma or the GANs or whatever to touch or be in contact with the matter level. That's the idea I have. Maybe I'm wrong, but
I think that's correct.
Yeah.
I mean, that'd be one purpose at least, but it may not always. You know, that might be one purpose at least, as a protective coating. That's the way I've always looked at it. In fact, if you're to look at, for example, we talked about nanopyramids before.
Oh yes, that's what I'm gonna ask you about the surfaces. You draw some pictures of different shapes on the. What was that, Rick?
Which thing was that? You mean on just today?
Exactly what you're drawing right now, because you already talked about that, but I didn't follow what you said. You said that in the surface it creates forms.
Yeah, there's a couple of ideas here. One is that the seed particles, the seed geometry for creating nanoparticles determines the way the rest of the nanoparticles grow on your nanostructured surface. That's the way I understand it. So if you were to create little nano pyramids in a certain nicely ordered format, for example, in a piece of copper, say through the first process, whatever you do to create them to start with, and then when you do your vapor, you will get more duplication of the same thing, basically. And then when you get a pyramid, and then you get another pyramid building off the side of that pyramid, and then another pyramid off the side of that pyramid, then you start to get actual little structures that form from the pyramids. And you can get fractal type structures. You can get very powerful structures. But going back to these pyramids on a surface, like copper, for example, if you can create these pyramids, they're really special. They have special properties, which is different than just a mishmash of spheres and rods and ribbons and a bunch of other stuff, and all sort of in layers, but sort of jumbled up layers, you might say, which is generally the way it might form. If you can form specific.
How they are created?
Well, in this case, you can look up tetrahedral or pyramid-shaped nanoparticles, and there's several actually quite simple, they call them facile processes, for creating these nanoparticles. There's ways you can do it with gold, with silver, with copper, and so on. And let me see if I can come up with something handy here. And just have a look at my thingy here. Oops. Right, okay, this is a great paper that I'd like to bring in now. Let's see if we can get this set up here. Okay, so this is a little science paper here on set up in live stream as well, something like that. It's a science paper, came out I think a couple of years ago. Facile one-pot synthesis of gold and silver nanocatalysts using edible coconut oil. Now you think, what the hell? How could this be? So we have an echo there again. It's blood mill. Your microphone's on. Echoing.
No, it's off. I
Is
guess.
it? Okay, I just saw your video came up and then the echo started. I haven't looked from there, but maybe somebody else is. Let me see on the list here. Maybe Emmanuel. Your microphone's open too. Okay, it's okay now in any case. So yeah, we got this one pot synthesis of gold and silver nanocatalysts using edible coconut oil. Okay, well that's an interesting concept. So it's an environmentally benign method for synthesizing these nanoparticles, eco-friendly, blah, blah, blah. And the way it's done is very simple, using virgin coconut oil and laser basically, and you shoot the laser in there and it creates these lovely little nanoparticles. And they go on to say, I've got the rest of the paper somehow, but I have somewhere, but I have to look it up. But they actually go on to say how you can control the size and shape from triangular to nearly spherical is achieved by varying the quantity of coconut oil. Believe it or not, fine control over the nanoparticle size and shape from the triangular and nearly spherical. From the triangular to nearly spherical is achieved by varying the quantity of coconut oil. It's that simple. Now, this coconut oil happens to be at 373 degrees Kelvin, which is, I guess, about boiling temperature, 100 degrees or something like that, Celsius, I think. It's minus 273 at room temperature, maybe 120 degrees Celsius or something like that. I'm not sure. I'd have to look into it here. Basically, they are able to.
Coconut oil is
Pardon me?
solid at 70 degrees. No, the coconut oil is solid at 70 degrees.
Well, at 260 degrees, you mean, in Kelvin. Kelvin adds 273 degrees or something to our regular Celsius. So basically they heat, go ahead, sorry.
373 Kelvin is just a tad shy of 100 Celsius.
Okay, thank you very much. So they bring it up to just about boiling temperature, water boiling temperature at least. And then what happens is the formation of the silver nanoparticles is signaled by the brownish yellow color, and that of gold nanoparticles by the purple color. That's how they can tell that these nanoparticles have formed in this coconut oil, essentially. It's very simple. You look at the color, and that tells you when the particles have formed, and you can vary the size and shape of these particles by the quantity of the coconut oil.
I have the ingredients. I have gold, so I need a laser, just a pen and done.
Yeah, right.
Do you need a special kind of laser?
Let me see how they do this again. Yeah, I'm not sure what kind of laser it is. I'd have to look into it here, but basically it's a laser ablation technique, they call it. It just forms the material as soon as you stick the laser in there, essentially. So this is, you know, it's quite amazing actually that you can create nanomaterials with coconut oil. I think it's great. I love it, and I'm excited.
But remember, Mr. Keshe was talking, or somebody else, I don't know who, talking about the reactor and the coconut container. Something.
Yes, that's right.
Yeah.
That's
because
right.
It's
So
already in a GAN state.
well, that's true. I was mentioning that the coconut water, and especially the coconut flesh when it's really jelly-like, is GANs, and the coconut water is so much like our body, like our body's GANs, that you can use coconut water as a blood substitute in a pinch if you really had to. And they have done that in the field in wars, and they still continue to do that. It comes in the coconut is completely sterile and usable as is right out of the coconut for I'm not sure, they might filter it first, but used as blood plasma.
Very interesting.
Blood plasma, I might mention.
Can I add to the knowledge?
Oh, absolutely. I'm sure you can do much better than I.
If you go back into the teachings of a couple of weeks ago, I explained how, because Alex was explaining how he nano-coats his layers with fire. If you do the same, heat up your copper wire, and then if you remember, I explained if you ditch it into a cold water, you get splashes of nanomaterial at the bottom of the container very rapidly. You literally see it created.
I've done that with pennies. Heat up the penny, put it in water, and it flakes off chunks.
You can do the same thing by controlling the temperature of the water you dip the copper in. Then you see different structures of nanomaterial are created. If you put ice cold and dip the hot copper in it, you get different kind of nanomaterial released. And then if you create a boiling water and just dip the nano-coating in it, you don't need a laser beam. You don't need a coconut oil. More or less a normal water, maybe 1 or 2 drops of natural oil will do the same. So you can see the different structure in the nano-coating after it's released from the body according to temperature of the outside. Because now you change the environment of the release. When you make a nanomaterials very fine, or at a very low temperature, ice temperature, and then when you dip it in the boiling temperature, the gap is less, so you get a different structure of release, but still the release is there. So you see the different kind of structures you've been talking about. By changing the oil temperature, you can do it yourself in a very simple way with ice and boiling water. Just dip the copper in it, and it gets to a point that there is no release because the temperature conversion is not so rapid. You even see, if you collect at the bottom, some ganses at the higher temperature at the bottom, not just only nanomaterial, but your gans looks color-wise different because it's an isotope of the copper. It's not the copper as a normal copper.
Right. Well, that makes sense. Yeah. So if it's an isotope, it like gets, you're capturing a part of a process. There might be many isotopes during some of these processes, but if we can control.
No, this is a GANS isotopes, not matter isotopes.
Okay.
There are different color. There is slightly different color. You see it.
Okay.
And if you do the process rapid enough, you get a pure copper GANS, not the CO2 GANS. The process releases you.
By rapid enough, you mean with more heat or?
Originally, I tested this with creating high temperature electric current through the copper. Usually, it's the transfer of heat from the vacuum condition of the nano layer to the atmospheric condition of the water. Nano layers are in a vacuum condition where the matter state of nano layers are in the environmental condition, so they cluster to keep that vacuum condition center. And sometimes this doesn't happen because of the rate of conversion of the environment. This happens at the upper atmosphere of the Earth. Nitrogen is created out of as a GANS. And then as it moves further down into closer gravitational magnetic field of the Earth, it gives part of its energy, becomes heat of the Earth, and then it becomes a matter state. Most of the heat of the Earth, what we feel as heat, comes from the conversion of the gaseous state of matter into the matter state of matter as it moves further down to the lower levels of atmosphere. The same thing happens in the copper layers when you ditch it into the water. One of the reasons we have heat at the surface level of the Earth is because of the conversion of the GANs to matter state. In your systems, when you make it, you see the lighting of the what do you call it, LED lights or running a fan. In the natural condition, that energy becomes the heat of the Earth. That's why close to Earth we have certain temperatures. Mainly this temperature comes, it's the same as interaction of the fields of the Earth and the Sun on the top, which they create the light and nanomaterial. As you come close to the structure of the Earth, the physical structure, where is mainly inertia than gravitational magnetic field interaction, that is so rapid that creates the heat. And this happens all the time. If this interaction was not there, we'll be below freezing. But it's just an Earth condition. This creates a heat just above and under the surface of the Earth. So you get the same thing with your copper wires. Depends how you bring how fast you close the gap between the atmospheric and the copper, because that nano layer is an atmosphere, exactly like the atmosphere of the Earth, but it's solidified. And above it, if we get the powerful, what do you call it, systems, that we can look at the full structure of nano-coated copper. You see the copper in atomic structure, molecular structure, then you see the nano layers, then you see huge number of loose atomic carbon in the air, but still attached to the wire. They cannot be freed as a GANs, but they're still floating. You don't see them as a nano layer. I explained this in a private teaching some time ago. It's not that what you see as a layer is the last layer of the nano material. They are attached to it free. When you touch the copper wire, for example, nano-coated, in the first touch you absorb most of these gases. Most of the gas layers. When you press the nano layer together, then you destroy this layer. What you see as a black material when you touch nanomaterials is mainly the gas release, loose but not separated. There is no borderline of there it is from the gas. You have like a cloud, and mainly the black part you see on your hand is this cloud you collect, not the real nanomaterial from the surface, because the real nanomaterial on the surface is hard as a diamond. You can't separate it. You've seen it, you can't even scratch it off. So the temperature you create in the water, it releases this cloud, not the nano layer. And that cloud, because of the change of conversion, shows itself in different formation. And which when you look at the dipping, you still have the full, as Rick was explaining, different formation to a ball. Depends how they separated each other. So you got to understand the totality of the structure. When you dip, you do not touch what is nano layers on the surface of the copper. Impossible. It's as hard as diamond. It's a closed tight, like a solid structure. What you release is the cloud, which you don't physically see. When man produces systems, we can see this, then you see the cloud around it. And as I said, when you touch the nanomaterial, nano wires, The black on your hand is that cloud you collect, not the nano which is stuck to the copper itself. Then by the temperature you create outside, you decide how this cloud is going to manifest itself. And the one which are on the outer boundary manifest themselves as pyramid. The ones which are closer to the surface physical nano layer appear themselves because of the compactness, they become like a ball. You will see this if you test it. You will see the spectrum is not just mainly one type, but depends on the temperature and which layer of the cloud you take off the nano layer.
Okay. Yep, you're still there. I've got there was a question that came up earlier when we were discussing about how important is the thickness of the nano coatings. In other words, how many layers that you have and the thickness of layers and so on to absorb energies from the environment is the way that Annabelle was talking about, I believe.
This is very much unknown. It all depends on the environment you created. It depends on the way you created the nano coating. Even though the nano layers look black when you use fire, or when you use caustic, or when you use electric current to make the separation of the molecular to atomic, they all create different gaps. No, they all look like human, but they all have 10 fingers and 10 toes, but there are different sizes and different positions. So you cannot say. It's impossible.
Are there pieces of equipment that we should be using to have a better look at these structures, like to be able to see the actual geometry, the actual material, how it looks like?
Yeah, there are materials, there are systems available.
They're quite expensive,
but it's not good enough yet.
Right.
Not good enough yet. But in so many ways.
They just came up with a spectrometer that you can use from your iPhone now. So perhaps in a year or two, there will be nano structure microscopes that can see very cheaply and easily these structures.
Yeah, but when I was a student, it was a funny thing. We used to call it electronic microscopes or whatever. I think today tabletop microscopes or handphones does better than what we used to have. So it's just the time to see how we develop, and we have to understand, do we need the spectrometers, or do we need to develop a new nano layers of different strength? That the interaction between their ganses, we see the new revelations.
So in other words, more by direct experimentation rather than taking measurements of the existing structures.
In the universe, we don't measure anything. We compare in comparison, because it's the environment which creates the measurement. You measure, and then you always have to work at the reference of what? You can always work at the reference of the hydrogen, but it's applicable into a full hydrogen or deuterium. And then different deuteriums have different characteristics in this universe. You always work in comparison. You don't have a reference point. There is no zero reference point. It's impossibilities. You always compare in respect to our body, compare, and in respect to the Earth atmosphere, it stays as it is. When we take our body into, let's say, the moon, in respect to its environment, it will behave totally different. You always do in comparison to the environment. There is no, they will never be able to create a measurement. Maybe there's a point of in comparison to the hydrogen in the body of the man or the water in the body of the man. But there is no, you cannot build systems, it's impossible it is. You compare into what environment you create and what you expect in that environment in comparison to the outside. The copper as a nanomaterial in Earth gravitational magnetic field becomes a nano as we see it. Then when in comparison to the cold temperature in the same atmosphere, we get its separation, we get nanolayers.
And in the vacuum of space, it might be a different condition again, so it would look different. Perhaps.
Yes, totally different. We will show this soon. We will have the vacuum machines.
Another question which Annabelle brought up, can the nano-coating process, especially the drying part of it, be done in a vacuum? Can you set up a vacuum chamber? And
we have a Ghanaian scientist, or what I call not a scientist, but he's a university graduate, so he's a scientist in so many ways. He's writing a book. Hopefully he finishes it before he goes to Ghana for the foundation in the coming weeks. He explains different kind of nano-coating and what to expect. It will be the first manual we'll have, and then we can always add to it. When he finishes it, he's coming to Barletta. We're gonna go through it, hopefully, if he's done it, and then go into detail what to expect, how to nano coat, and every details of what to expect in different ways of nano coating. So this way, then you can make a comparison.
What, Mr. Keshe, may I ask you, who is the author, or is already published the book, or is in print?
No, he's writing it because we are sending as a Keshe Foundation ambassador with Alex to Africa. When we come back from breaks, they go to African nations to teach. We have so he's coming part of the Keshe Foundation structure from September, and then he goes back home because we established the line of work with the Ghana Space Institute and Ghana Energy Ministry. So it's good for us because we have foundation supporters all over the world. We use the nationals, then trying to get somebody in there to go because they know their ways and they know how to teach and they know the language. So we're using that avenue. But he's a European educator that lives in Northern Europe, and he's writing the paper. He told me that he's doing a paperwork for this. So when he finishes it, by the time he joins us in September, we will release it on the net.
So it will be published by the foundation, right?
Yes, yes. Yeah. Let me see how he does. Yeah.
Yeah, sorry, Rick. Just a quick question. I have a neighbor, and she got this Alzheimer. I heard you talking about the health pen.
He's got what?
That can be, Alzheimer.
Yes.
She's in the 70s, and I feel so sorry because nobody can do almost nothing for her. And I was thinking, since you said that the health pen could be useful for that, also this sickness, do you think that building this hat, of course, very well isolated, with 2 or 3 health pens inside, or just the rods?
Listen to the teaching of tomorrow. Tomorrow is a huge change of point again for the foundation. I've seen Rick hasn't put a notice on. It's called, the title is called, Rick, have you decided on the last final version of the title to go out today? Hello, Rick?
Sorry, I had to unmute there. No, I don't have a final title. I just put the workshop out as more or less a continuation of the health, as similar to last week with more testimonials and so on. So you're referring more to the spaceship enterprise? Is that what you're?
We don't have a spaceship enterprise. Give you a heading if you can go out with that today for tomorrow. We called it the humanity is ready for deep space travel.
Okay, right.
So it's important. And then in the health side of it, I'll cover this. But when you have Alzheimer's, Alzheimer's is a specific disease. It's not a disease. It's a condition of brain that a man or a woman would like to forget. The reason it belongs to them, you cannot force it to come back, but you can facilitate the brain to open the channels. Alzheimer's is a kind of ILS. ILS, you physically disconnect in the arm and the leg. With Alzheimer's, you physically disconnect part of the brain, but it's still there. If somebody who gets ILS, you don't see their arm and legs falling off. They're still there, they still get fed, they still doesn't rot. They do the same thing with their brain. You have to find out what's the reason of this disconnection.
Actually, I already talked to her, and she has a very, very hard resentment with her mother, and she doesn't want to forget that, you know, and she's stuck on that belief or a feeling, strong feeling of not letting it go, and you know, I don't know if it worth to do something in that case.
I didn't understand. I couldn't hear you properly.
Do you hear me better now?
Yeah.
Yeah, what I was saying that just exactly what you said is that I already talked with this lady, and to find the reason, emotional reason of why she's laying in bed, you know, letting herself die. And I know because when she was well years ago, she was always talking about the problem that she got with her mom, and she never forgave her, and she's very, you know, resented about that. And now she's in bed, you know, waiting to die, I guess. And I already talked to her, and she's still stuck in that, you know, thought. And I don't know if it works to do
If
something.
she's stuck in that thought, it means she doesn't got Alzheimer's. She's chosen to have Alzheimer's because this way she can forget. But inside, she's one of the ways you can see people with Alzheimer's are playing with it or they are in control of it. Ask them to sing a song they ever liked. If they can sing a song, then it means they are controlling their Alzheimer's. They are the decision maker. Ask them to, let's say, do you remember, the usual one I use, and usually they don't understand, they fall straight away in it, is I said, if they're married, says, do you remember the music played in your wedding? Because the music which is played in a wedding, a marriage, always stays in the head. Because there was a reason you played that music in the wedding. You understand?
Yes, yes, but actually, it's very interesting what you're saying because the weird thing, very weird, it's supposed that because she has been diagnosed with Alzheimer, but at the same time, she got a perfect memory and supposed to lose memory over time. She still got a very sharp memory. That's unusual.
No, because when you see this kind of Alzheimer's, they will physically create a condition to disable connections in the brain. It's a selective Alzheimer's to forget the pain.
And do you think that it will help her, you know, to use these health pens?
You can do, but it has to be done in a subtle way. I've done this a number of times before. It has to be done in a very subtle way without them knowing, because then they oppose it. Usual way with the Alzheimer's is not so much physical, which means you don't go through the water. It's very much through the emotional, which go through air. You have to build. We'll speak about this more tomorrow. If you bring it up tomorrow, then I teach with everybody at the same time. You have to separate the emotional part of the recovery from physical part of recovery. It can be done with a lot of expertise And a normal man on the street cannot do it because they can get it wrong and it can cause more problem.
Yeah, that's why I'm asking before doing anything.
It can be done. It's very easy. Alzheimer's is one of the easiest recovery mental conditions. Alzheimer is a psychosomatic, but the psycho sits in the brain and somatic is the brain itself. That's why it's hard. Doctors don't know how to handle it. Alzheimer, when you have a psychosomatic diseases, you see, for example, disability of an arm, or you see pain like a fibromyalgia. But Alzheimer is a psychosomatic, but the somatic the part is the brain itself, which one part paralyzes the other part for it to show its power or to show its control, but it's still functioning. That's why you see Alzheimer's in MRIs. It's a psychosomatic, but initiated by the emotion and body carried in the brain itself. Where like ILS is a psychosomatic, but you see it in the emotion of the loss, but shown in physicality of disability with the same as MS. That's where the world of medicine never could control it. Alzheimer is a psychosomatic disease, nothing else. And if you correct the psychological part, you see the emotional part disappears. One of the best part, I think, of this is what we heard last week with producing the wheat, as it was explained to us how to make the water of it. So you can do it. It's very easy. It's one of the easiest problems, psychological problems to sort. We have a case in Canada where the father was perfect till he was brought up to Canada from China, and within 2 years he became Alzheimer because he did not want to be. So by becoming showing signs of Alzheimer, he literally could live in China but physically in Canada.
Oh, that's interesting.
But you could see all sorts of things in the brain. They did all sorts of MRIs and everything.
So
But
it's like she's blocking part of his brain.
They don't blocking. It's just that she's put a barrier, and the barrier is there. You can't do much with it. There are ways of reversing it. There are ways of opening the channels of the energy flow within the brain. But then you have to see what is a kickback. If you don't sort out the emotional part, you'll find out she builds under the barrier. And this is the way they usually kill themselves. Alzheimer's people who die with Alzheimer are the people who disable the functioning part of the brain through the emotional part. They don't go outside like ILS to do it physically in the physical part. They disable the brain inside themselves without anybody knowing. And you have to find a route, and you have to offer them a path out of the problem, out of what they see as a problem. But the thing is that when they get to this point, they become so self-centered that they are more important than the victim they claim to be. It's a very, very tricky business with Alzheimer. They do everything they will do. They are extremely, extremely intelligent people because they use their intelligence to stop their own life. And in that process, they save a lot of energy, so they increases their intelligence. You got to realize something. Diseases like Alzheimer, like not the disease, conditions like Alzheimer's, conditions like schizophrenic, nymphomaniac. These conditions create, to achieve it and to control it, uses a lot of energy, and that surplus energy which is used and brought in to do brings huge amount of intelligence. Huge amount. These people are amazingly intelligent. The children with what they call these new words they created for them hyperactivity, ADD. These are extremely intelligent people because they concentrate all the energy into the brain. Don't forget, human race became intelligent through the consumption of the meat. When we start consuming meat in a vast quantity, and then when we start cooking it, we took the energy from the fire to add without us doing the digestion. That surplus energy which we take from the fire has added to the intelligence of the man. Surplus energy is used in the direction of intelligence. Apes eat the same meat as we do. Lions eat the same meat as we do. But they don't gather intelligence. The only reason we became intelligent is we start cooking the meat. So the energy needed to digest was already added by the fire to it. So that energy of the fire became surplus, and in being surplus in the body of man became intelligence. So on the same road, people with Alzheimer's, people with schizophrenic, people with nymphomaniac, people with what they call ADD, which put a huge use of the brain, they're highly intelligent. They're better than a normal man by order of magnitude in intelligence. So your guy, your woman, is highly intelligent.
Yes.
This is what we don't understand, and we allow it to run away in our structure of the society. We are the victims, not them.
People around them.
Yeah. They learn how to manipulate the others through their intelligence. Alzheimer's people are extremely. I had a case in. She's. They brought her to me. She's in her 60s, and we asked her, "How do you make a pancake?" She says, "I don't know what a pancake is." But they said she loved to make pancakes. This woman, 3-4 months later, the husband had to go to a hospital for whatever reason for a couple of weeks. She went, paid all the bills, she did all the cooking, she looked after the house, she made all the bank payments for everything else needed to be done. And the family were surprised. The cause of Alzheimer's, she was like this for years, was she did not want to live with a man in the house. This way she could detach herself, and it was Alzheimer's. I put them on the table with the doctor who brought her to me, with the husband, with the daughter. And I said one thing. I said, I'm going to go too deep to this in 1 second, you all see. I said, do you know who the Beatles are? No. We sang the song of Beatles? No. I said, do you remember your wedding song? And the husband did, and he started humming it from 50 years ago, and she started following it. I said, woman, I got you. Now I gotta find out where your problem sits. The problem was sitting that the man was too dominant. She saw no purpose for herself in the family. She made her own cocoon. They call it Alzheimer's. And now she could cook, she could live, she could do everything. And one of the ways to do it is to allow the brain to take what it likes. The helmet you talk is one of the ways. But tomorrow discussion in the health, we explain a lot of things about the new technology, how to use it. It has to be on a balanced way. And it can be done. But you can't do it with 1 or 2 pens. It has to be done with the consent of the soul. Because we were not there when the abuse took place. Was she the abuser claiming to be abused, or was she abused because it fitted her to be abused because she could get the love of the mother? When they find, yeah, this is how.
Well, I actually don't know what the book was.
We never know. We were not there. We will never know. They can still tell us something, but they still will never know. I see a chain on the screen.
Yes, this is some of. Let's keep my live stream. This is some of the work of Michael, who works with copper.
Thank you for the answer.
You're welcome.
And let me see, you've got, as you can see, he's got lots of copper wire that he's been using to create all kinds of different configurations. And some are quite interesting. And you mentioned, it's been mentioned just now about this this thing that we can put on someone's head that might have Alzheimer's or other problems, and maybe it would help them. Michael happens to be a hatter. He makes hats as one of the things he does. And he's got a concept for using nano-coated copper threads in the inside liner of the hat in order to try to
How we call it the happy hat.
happy hat, as opposed to the dunce hat, or the there's the other hat, your thinking cap, which might be another type of hat. And perhaps those are three hats that we could have. Actually, the happy hat for being in a good mood, the dunce cap when you don't want to think and you just want to meditate and want all your thoughts to stop, and then the thinking cap when you want to have lots of thoughts and your busy brain is thinking all these things. Maybe it's a way to stimulate that, if that's a good thing. I'm not sure sometimes, but it could be for stimulating thought as opposed to meditation, which is usually without thought and so on. So maybe these hats could be something that could be used by people. Now, whether this is a good thing or not, I'm not clear. Mr.
I
Keshe
saw
mentioned
these.
before about
I saw you.
changing mood and so on, changing people's the way their mindset and their emotions basically can be controlled through this kind of technology. And maybe people would want to control their own brains, their own brain waves, their own plasmatic structures basically through the use of such things. You know, you put your happy hat on when you want to be happy. You put your dunce cap on when you want to stop all the thinking and just get away from it all. And you put your thinking cap on when you go to work and you're busy developing, building bridges or whatever it is you do.
But would the thinking cap of mine will be a happy cap for you?
Well, no, not necessarily. That's the thing. It would have to be all custom made. And of course, that's a whole business.
You know, you go to the tailor and says, "Oh, let me put a crease there," and I open that seam. Would do we go to a hatter to say, "Okay, make me a happy"? Oh, I feel a bit sad here. Can you change that part?
Yes, well, I think a hatter with knowledge might be able to do that. Like, you know, Michael, for example, he creates various nano-coated structures and so on. We had one. I'll just put up the other one here that we have. For example, this one, very interesting nano-coated structure. And but he creates a lot of these things without necessarily knowing what the use is for them or some of its potential, what it could potentially do. But he knows that somehow that this feels like a correct structure. It feels right to him when he makes it. He puts his energy into it. He puts his intent. He puts his basically his love into it. And in that sense, when he works with these items, he also feels them at the same time.
Yeah, the reason it does that is in the structure. You see it.
Right. Yes.
And it's the type of wire he uses. All his structures, I've seen his pictures you put up in past couple of days. He uses double wire.
Yes.
That double wire has emotional attachment to it. A single wire is a physicality. When you use double wires the way he does, in two wires, one behaves like magnetical, one gravitational. In between the gap, which even looks to you nothing, because the two wires are twisted, it creates a free plasma, which adds to the energy of the man. If you go back on the structure which Renan showed us, with a pin with the coil inside the coil and the pin in the middle, it says there's more energy, more powerful. Twisted wires like this carry a certain amount of energy, especially when you nano-coat them, because the energy release is entrapped between the two wires. And then because of the shape of it, from one knot to another, there's still a field in between. The minute I looked at the wiring and the pictures he put, I said, I hope the guy knows what he's doing. If you hold these things in your hand, the way it's made, the double wire, it should give you a lot of energy. It should give you a pleasant energy.
Well, it seems to, for him, I believe, he seems to be quite tuned. I wish maybe, Michael, you want to say something here. Just trying to see if you want to or able to. At some point, I'm sure he'll want to make I think we're going to make a bit of a demonstration or a presentation for the Knowledge Seekers Workshop, and some of his work might be interesting. Hi, Michael, you're there now?
I'm here.
Let me just say, Michael has a bit of a hard time speaking because he's had a throat cancer issue that he's dealing with. So, but go ahead there, Michael.
Yeah, as you know, that's what I do. That's what I love. I've been creating these devices for years, and I've got it everywhere. It's just something that comes from inside, different shapes. Now I come across Mr. Keshe and you guys. I can see the connection with your work. So, sitting there with the throat cancer is not a problem with the cancer. I need time to create and to get involved in the time we are going into now, So basically that's it really. I'm always creating something.
Have you, with your cancer, what's the condition? Have they removed the cancer from the throat or?
Yeah, there's no cancer at the moment. It just left my voice, my vocal cord damage. But apart from that, I'm fit and healthy. Obviously I'm working for a company and I take about 3 months off just to since I come across your site, I stop work. Well, I don't stop work. I just take time out to get involved with what I'm seeing, what you're doing, because I feel quite connected to it, and with the nano-coating stuff, I can't stop doing it because I just run with it. And it's great, it's wonderful. I'm fit and healthy, just my voice, but it's not a problem,
You can build the vocal cords easily.
Okay.
I've done this for an Italian prince, or what they call it, one of these. She had the same problem, and in the operation, by whatever, they touched her vocal cord, and after about 6 months she could speak clearly. You can build tissues of the vocal cord very easily using the nanotechnology and the GANS technology.
Been like this 4 years.
If there is no cancer left, I mean, it was just a local cancer and it's been removed. The vocal cords can be rebuilt to an extent to improve. You hear the voice changes. Because I remember when she came to me, she couldn't, we couldn't hear her. She was like, and then at the end she wrote me, I can talk, I don't need you, Mr. Keshe, anymore, thank you. So there is a possibility they can do it. It's got to be done in a certain way through the water than anything else, that the body takes what it needs to redevelop. And you can do it with a GaNs of copper, and the CO2 GaNs with a mixture of water. But it needs a specific control, and that muscle tissues just build up. You got to understand when you work with these things, that's which part you're touching, the emotional part or you touch physically. Do you know why you got the cancer of throat?
Well,
did you go through a suffering you could not speak your word?
He's mentioned that he has to take time off in order to do what he's doing now, and that the cancer was actually a blessing in a way that he has to take the time off now.
Yeah, that's
no,
it.
no.
You mean
I was
before
going
that?
Yeah. What was the reason of having a throat cancer? Did you go through a condition you couldn't speak your piece?
Well, could maybe family issues, you know.
Yeah, I understand.
A relationship for 38 years, you know.
You could not speak your word.
Exactly.
Yeah, that's a sign. We always direct our cancer to where our point of weakness is.
Yeah.
And so it always goes that way. But you can improve your vocal cord quite drastically. Not to a normal, but quite very clear without the pressure. You need to structure the physical development and the emotional, because if you build it, but the pain of the emotion is still there, it will manifest itself as another cancer somewhere else.
Yeah.
You have to deal with the emotional part through the GaNs of the lung, and then you'll find out the physicality is a matter of a few weeks.
Can I say something? I think I don't see a problem with the cancer, because going into myself, I realized I needed time out for initiation, so I could, because that's how I come across the copper, and I work with. Well, this is my philosophy. I work with the female energy, who teaches me in the hours how to create these shapes.
Can you tell me something interesting? When you touch copper, do you feel the copper as a metal, or do you feel the copper as an entity?
I feel like a female entity I'm working with. I feel it. I feel I'm working, like when I do my hats, I work with the unseen. Yeah, the things just happen. I just, I become a part of this entity. This is a female energy I work with, and literally speak to me at times. The copper is.
Well, you make female hats.
I make all kind of hats. I make hats.
Hat to fit the head.
Yeah, I'm not. I do it at this present moment. Got responsibility, so I love it, but I don't get paid for what I love, so I've got to find some way of earning a living. And so I had to go out there and do some cleaning for a cleaning company at this present time. Which I'm working with a lot of chemical.
We are opening a channel in the shop of the Keshe Foundation. It'll be announced. I mean, you will see more and more of it. We're just setting it up in the background. If that gives you a chance to, with what you do with nano-coating, and you want to put your articles on the Keshe Foundation shop, we can give you facilities that people can order through it, that it gives you an income. You don't need to work that way.
Okay.
It's just that give us a couple of weeks to sort out everything in the background, and you make examples of what you do, and because it's a handmade, You put a value on it, and the foundation will put it through the shop. Because
Yes.
we are making the Keshe Foundation shop a center for all the nanotechnology developments and people who don't need to go out to find somebody. They can finance themselves and the foundations around the world.
Yes.
So in next week or two, keep in touch with Rick and Vince, and items they can put. You make a catalog of a few items, and people can do. I saw you make a sphere back to back. The first picture, the one you see there, because we were talking to Arman. Arman showed me how you make these things.
Exactly. So
Yeah.
those rods, also those rods,
Yeah.
the fields is going back in itself, you know.
Yeah. So if you do these kind of things, we don't want to become a retail shop, but we allow people who, because I see a use in especially that sphere you made, it's on with a $5 Canadian dollar, is it, or a British pound?
English about £5 notes.
Yeah, you're an Englishman.
And the Queen Head. No, I'm from Jamaica, but I live here 47 years.
Where do you live in England?
I live in not too far from Alex, 10 minutes.
Oh, in London, North London.
Enfield, yeah.
Enfield. Oh, I used to live around there years ago. Yeah, I used to be around Enfield and what do you call it? Seven Sisters on that side.
Yeah, I live in Ponders End.
Ponders End, yeah. When I was a student, I used to live in that area. Yeah. The what do you call it? What you create, especially in a double winding sphere. I was talking to Arman, and we were talking a couple of nights ago, because he's making them, and he was showing to me how he makes them to look a sphere, and how he can put one sphere inside another sphere. So you can. This has a lot of application in space technology, and I think you just happen to come in the right time. But the way you use double winded wires, it brings emotion into the game. I'll explain this in the teachings.
Out of myself, you know.
And he also has a special technique that might end up being quite important, using coconut oil as part of the coating process. That's what makes it have that sort of shinier look you can see on the image there now. I was going to have him talk about that a little bit in the Knowledge Seekers workshop, perhaps, if you wanted.
Yeah, I think we got to add to the knowledge in different directions. As I always said, we're going to get a lot of essence out of Africa and China, because they go through the route in a different way. So it's keep in touch with Vince and Rick, and in time we're opening a special section of the Keshe Foundation for these kind of developments.
Thank you.
We know that then you don't need to, if you can establish a system that it can be used, and we can explain the usage of it, and people don't know how to make it, they like to buy it off the shelf. The link, I was talking with the people in the background with Ella and Vince a couple of nights ago, that the order comes directly to you through the foundation. Then if we can help you and allows the knowledge seekers to add to their knowledge using the simpler version, it'll be nice.
Yeah, thank you very much.
Thank you very much for your time.
Glad to speak to you. Been a long time coming.
Thank you very much for your time. I've got to go. I'm on working holidays.
Yes.
I still work. Tomorrow will be a very interesting time. Tomorrow, if you can promote it around the network, tomorrow will be a change of revolution for evolution of man. It's amazing what we've done, what will come out, and what we're going to explain.
Can we call it, is humanity ready for deep space travel?
No.
Shall we just
humanity is ready for a deep space travel.
Are you sure about that?
yeah, I don't usually go somewhere I
How
can't
about
swim.
technology to bring us to deep space?
Oh, the man who's pregnant is there. Good morning, Vince.
Don't make me laugh, please don't. It hurts so bad.
How are you doing?
Oh, lots of
Sorry,
pain.
I
Lots of pain
couldn't
pads.
resist it. When you rolled me that thing, I thought, well, it must be
I know.
pregnant.
As soon as you seen that, I know.
I get it.
he wrote to me, I'm vomiting every 20 minutes. And I remember the only time you vomited when you're pregnant. I said, you must be pregnant.
I've been through this
That's
many
what I
times of
said.
food poisoning, actually, and it
I
sucks.
said I often feel a little sick just before a big breakthrough. So maybe we're pregnant with ideas or something like that.
Vince, we need to talk later on today when you feel better.
Sure.
For tomorrow teaching.
Yeah, okay. I know we have lots to do.
Okay, lots
Tight
to do.
schedule.
Please, can you open that link for testimonial on the forum?
Done. I gave it to Carolyn.
Put it up everywhere. People can put their testimonial up. A lot of people want to put things in.
Yeah, Rick, I want you to, I put you
You
as
got
a,
to promote it everywhere that people can put their testimonial.
I think
Be
we
careful, there are people who are going to put fake testimonial to damage as well.
actually, Mr. Keshe, I want to tell you about, we're going to use some of Ludmill's testimonials as well, which he's got some very nice.
Yeah. Well, I told you, welcome it. It's there. He used part of technology. And I said to the same thing just now to regarding the wires. I explained to
Hello?
you yesterday. Invite Ludmill to.
You're breaking up a little bit there, Mr. Keshe. You just lost a
I said, can you hear me now?
Yeah.
Yeah. So we were discussing with Vince as we were talking with Ella about the shop. I said the paint pad which Ludmil has made, if he wants, he can add it to the shop section of the foundation. These are the products people produce from the hard work and understanding of the technology. And we are there to support it. Our paint pad is not the only one. I've seen a new paint pad coming up. Brennan will announce it tomorrow, built by somebody else. And that can be added to the same pattern, the same pattern to the shop. Because by using the technology in different form, we bring trust to the knowledge and the technology. And we need to work as one team. It doesn't matter in what shape we use it. And paint pad we has received the CE certificate. I was told by Sohel, so we
received the what again? The what again? C certificate? I can't hear. I think we lost Mr. Keshe there briefly.
Yeah, he said a CE certificate.
CE certificate. That's
I think that's for the
electronics.
European Union. Yeah, exactly.
Okay, good.
Vince, would you like some pickles and ice cream?
Pickles and ice cream.
You're pregnant, right?
No, thanks, Brett. I got all the food I need here.
That would probably make him pregnant all over again.
Let's stop talking about being pregnant because the wife is really getting down my back about having another child.
Tell her it's going to cost you 30 years to pay for the first one?
Yeah.
Rick.
Yes.
Yeah, I didn't hear the answer. I don't know if we changed the subject, but what was the answer about the vacuum on the drying of the nano-coating? Did you hear something about it, or?
I didn't get a final answer. I think Mr. Keshe said he was going to discuss it more and something that that he wanted to talk about more. Does anybody else remember anything else about that?
So to bring the subject for tomorrow.
I believe so. I'm not. I wasn't clear on whether he wanted to carry on with nano or whether nano was becoming more of a Keshe topic or not. I'm not quite sure how that's going. How it's the main topic will be the humanity is ready for deep space travel. So whatever can tie into that, if nano coatings are part of that, which it seems to be still, then perhaps that question will be appropriate tomorrow. I think we just play it by ear and see how it goes. If you want to bring it up and you think it's correct timing for it, then go for it.
Okay. Sorry, I forgot to ask you for permission, to ask that question, but
You don't really have to ask. You don't have to ask my permission as such.
Well, you are the host. You are the
yes,
host. So.
That's right. As long as you're not all trying to talk at once or whatever, then that's great. If you see the opportunity, then go for it.
Yeah, because it was an important subject, and I don't have a clue. And you saw it was a complex subject. It's not that simple because the emotional stuff is involved. So. But hopefully tomorrow there is room for that. Because I think it's a very good application of, of helping. So that's why I'm impressed.
We could say, is grandmother ready for deep space travel? What do we do with grandma's Alzheimer's when we're in space?
Yeah. Well, it looks like it's something related to the emotion, and when he started answering, I was really surprised because it fits exactly in the situation of this lady, because it's an emotional stuff, but I don't know how to deal with that. I just want to give it a try because it's very, here I'm living in a park where there is a lot of, they call it rednecks or hillbillies, without offending anyone, but country people mostly. And, they are like helpless because they are old, hospitals, clinics, and they don't really help. They just diagnose and let them go, let's say. And I knew this lady since years ago, and she was a very good person. So now she's in a very bad shape. And maybe there is a solution. That's why if I know that I'm doing nothing, for me as a friend is, I feel very bad about it. At least give it a try.
Well, maybe you need one of Michael Moore's new hats that he'll be showing in the Keshe Foundation shop soon. He might actually be. He has a great idea about weaving the nano-coated wires into the inner part of the hat, so it's not actually touching your head or anything, but it would be inside the liner of the hat. And I think that's a grand idea. I think that if you can change someone's mood or allow them a little more.
But my concern was that, sorry for interrupt. Mm-hmm. These guys and the Philippine guys that invented the health pen, they talk about asking the person if they want to be healed or they want to be healed. That's one of the first and most important steps from the side of the patient, let's say, and the other is the intention, of course. But if you cannot talk with the person about this because they will close, their mind and get stuck. So that will be kind of difficult to be done.
Well, that's true, and it's actually true in virtually all sales as well. You want to prepare the customers so that they can accept the product and be really, really happy about it. I mean, that's the old vacuum cleaner salesman you know, it's not a
Well,
trick really. It's just a
but
technique.
now there is a but now there is a solution very easy for that, you know, because you first when you get the customer just give them the hat, you know, try this hat first, you know, and then ask the question and sell whatever you want, because he will be happy anyway.
Yeah, that's part of it. I think, like for example, if you have, in the case of a hat that we're talking about, maybe it's a whimsical hat. Michael's got pyramid shaped hats, for example, and so on. And they look like they'd be quite whimsical and kind of fun to wear if you were into hats, and that kind of thing could be kind of radical at the same time as it could. You can imagine if you were an elderly person who had Alzheimer's, your face might just light up at the sight of this very unusual looking hat that you were asked to wear, and see how you thought about it. And it might just invigorate your whole life enough to, you know, bring your brain around, literally.
And it's a good idea also to put some of these shapes, you know, under the pillow while you sleep.
Yes, there's a good idea. Yeah.
Yeah,
So
but
you could have it woven into a pillow or, as well. The nano copper fibers, essentially. It could vary. Maybe a shirt you could wear with, you know, I know they are using copper fibers for disinfection, because copper happens to be the best microbicide. It kills microbes better than any other substance. That was just recently discovered by the U.S. FDA and, or you know, the Food and Drug Administration or whatever. They just approved copper a couple of years ago as the only material, the only element that they've ever certified to be a microbicide. That includes stainless steel. Stainless steel is not a microbicide. It does not kill microbes and bacteria at all. In fact, it harbors them. Whereas copper will kill 98 to 99% of bacteria within a few hours.
in their surface, you mean they cannot live in the surface, or you're talking about powder?
Yeah, the surface of the material. So all the stainless steel you see in hospitals is basically contaminated. Yeah. They can't clean it. It's not cleanable. Whereas copper kills the actual bacteria, and it's cleanable as well. But you know, you can't clean into the little scratches is the problem. And yet, if the material itself with copper has a special reaction with bad guys, that it wipes them out.
And now I think another.
Sorry, what was that?
Just to let you know, some of the dentists require exact shape when they do operations with my pads. Usually dental work requires special shapes.
Special shape with the pads, you say?
Yeah, like with the size of the jaw and like following the line of it and face line and stuff like that.
With the pain pad?
Yep.
I see.
Actually, more, they're not much in the pain pads, they're more in the inflammation ones.
Sorry, Ladmil, you're talking about the dentist. They use pain pads on the teeth?
Yep. Yep.
Instead of anesthetic?
For stupid simple example, yesterday I got toothache and was gone for half an hour.
With the pain pad?
Well, I used the inflammation one, but doesn't matter. It's a fact.
So you create your own pain pads?
Yes, couple of them actually. About 5 of them at least, different.
5 different designs or 5 sizes, you mean, Ludmil?
5 different designs. One of them is for pain, one is for inflammation, one is for sinuses, one is for growing bones. There
Growing
is
bones?
energy cup, stuff like that. Completely different applications, basically.
Growing bones will include growing teeth.
No, growing bones when they're broken and recovering operational wounds.
But it makes sense you could grow teeth. It's essentially the same process as growing bones, and we'll have hopefully have a demonstration or a presentation tomorrow with Yvonne with about growing teeth in the workshop. I had to get it cleared by Mr. Keshe. He didn't mention anything today about it, but if that's okay, then we'll have a little presentation about how to regrow teeth. And it's something I've been looking into as well. It's quite a fascinating subject, and it does tie right in with nanotechnology and creating nanomaterials and creating the conditions for regrowing teeth. It's all exactly the same overall principles as growing nanomaterials. It's done from the inside out.
Quite possible to work for teeth. I never tried it though.
But you need to have the roots still there. If the teeth has been taken out, you cannot grow anything.
Well, that it's hard to say. That yeah, that would be more difficult. I'm talking about broken or decayed teeth, basically. It's like when you're regrowing bones, for example. I was just reading how they can a young child can regrow the tip of a finger as long as it's not cut past the first joint of the finger. Anything beyond that first joint can actually be completely regrown. The fingernail, the whole fingertip, and everything will grow completely normally back on a young child. Hello?
Rick?
Yes.
Mr. Keshe said, and it's true, lizards drop their tails when they're getting attacked, and they just grow them all back. So if they can do it, we can, hey?
Yeah, well, that's right. And they found that with fingers, if they were to take stitches and stitch it all up, that's not a good thing with the kids.
No.
The fingers, they're supposed to leave it raw, basically, and within 2 or 3 months, it completely regrows normal. Whereas adults have a harder time with the fingertip regrowth, apparently.
But I heard that once you, for example, there is a limb missing, but still the field is there. You know, the phantom effect that it.
Yeah, yeah, I get that with my teeth. For a long time after my upper left teeth molars were removed, but I was for a long time, and even sometimes still, I will get a toothache in those teeth if I eat certain things.
Yeah, so the feeling is related with the plasma, the field over there. Maybe with the correct, GANs or whatever it is, or magnet, let's say, can be rebuilt because the shape is still there.
Yep, and with the teeth thing, there's actually a patent process where they use an electric charge, like I think it's just a couple of volts and a certain fluid, and you put it in your mouth, and they use the electricity in your mouth, and it will reverse tooth decay. It can take out the tooth decay within 5 or 10 minutes of use.
Oh, that's what you were talking about before, right?
And then you can use similar electrical processes to actually rebuild the teeth as well. In the same way that you can use electricity to create nano-layers faster than normal.
Wow, interesting, very interesting.
And with teeth, it turns out the teeth material actually grows from the inside out. We don't think of our teeth as growing, but they actually will and do grow from the inside out. same as the
from the jaw.
nanomaterials grow from the parent material out. So you have two conditions. You have your inner conditions where the roots are, and you have your outer conditions where the atmosphere of the mouth is. So both of them have to be correct in order to regrow the teeth. You can't keep the same conditions as created. The tooth decay is not going to create the conditions for your teeth to regrow. So, but once you understand what the conditions are, it becomes much easier, right, to understand a few things. And that's basically regrowing my teeth in my own way. I'm trying to avoid dental work by changing diet and changing the way I take care of my teeth, changing the environment in my mouth and inside my body and so on, and watching what the results are and seeing how it changes the actual situation.
Yeah, that makes sense. And about there is another subject that I think that is very important that we are all using, but is the nano-coating process. And since we are working with copper wire mostly, and sheets of copper, and is malleable, I think that building something related with sacred geometry and the nano-coating process could be very interesting, because maybe sometimes we are doing it like Michael is doing very intuitively, but once we know how the cavity, the boundaries we are making affects the process of the conversions of or creation of fields, we can improve it a lot, I guess.
Well,
because all
yes,
these
that's for
platonic
sure.
solids and
That's right, exactly. I think it's the more we learn how to control the process, the more wonderful things we'll be able to create. And that's why it's become a trillion-dollar industry a year with the nanotechnology and all the rather complex processes that some companies use to produce their materials and so on. There's also a lot of very simple processes going on at the same time that are producing even better results. So it's we live in a very interesting time right now in that way, that we are sort of more or less on the ground floor of some of these processes. And if we want to dedicate our lives to it, to some nano-coating process, some GANs process, or some of these different things, there's room for doing that. If you're science type and you got some money you want to invest it into some company that wants to take it to the limit and figure out all the variables and create those coatings in a vacuum condition that are just perfect and able to cause a reflective surface or a absorbing surface or whatever kind of surface you want to, but better than what's been done before, then there's so much opportunity for it. It's just incredible, I think.
Rick, there was a guy in Melbourne I read on the news. He's a professor at Monash University, and he was announcing they'd created an artificial leaf that, when developed, they'll be able to use it for fuel.
Yeah, of course, the first thing they want to do when they convert carbon dioxide is to make it into fuel so we can burn it again.
Yeah, hydrogen fuel.
That's the stupidest idea I can think of.
Yeah, they're just stuck in the merry-go-round.
Not just hydrogen fuel, but actually creating, they use the methane created from the CO2 to churn that into actual fuels for vehicles is the thing, so that you can burn it again, so that you can take the CO2 from the atmosphere. It's not a very.
It's a merry-go-round, isn't it? Eh? Oh,
well, burning, it's like the whole reason I got into all of this technology to start with is when I heard Mr. Keshe say in his first video many years ago It's time for mankind to stop the burning.
Yep.
Very simple. And
Yeah.
that's really struck me and really hit hard, because I'd been so sick from diesel exhaust at that point that I had almost died. And I had been,
Remember, he was sitting in front of a fire when he was saying that?
yes, exactly.
Yeah.
Deliberately in front of
Yeah.
the fire.
Like Fred Flintstone or something in a cave.
Yeah, yeah. And I realized then that was true. We have to stop the burning, and that is the main cause of distress on this planet. In fact, it's one of the greatest tragedies, I believe, to ever affect mankind. But that's a whole other topic that I'd like to get
I
into.
remember you saying once, Rick, the most amazing thing, you're sitting in your car and you're in a traffic jam, and you've got the exhaust pipe of the car in front that's burning its fuel, and it's coming straight into your vent in through your air conditioning and everything else, and you're breathing the guy's poison. Then your car is doing the same thing to the guy behind, and everyone thinks it's great.
Yep, it's a group, I don't know
Suicide.
what you call it. Group suicide. Yeah, it's a way that we all go together. We all go together. You know? It's like, if you're doing to me and I'm doing to everybody else, then that must make it okay. We've done it that way for 100 years, and we did it that way when we had coal, and we did
Misery
it that
loves
way
company.
when we lived in the caves, and the guy next door started a fire, and it would be in my face, and my fire would be in the next guy's face, and his in the next one.
My fire is bigger than your fire.
It all gets passed downwind, and with humans, there's lots of wind going on. So
yeah, sheep just do the same thing.
I think it has been right back to the caveman days. That's why we accept burning so much now.
Yes.
You guys gotten used to it. It's something we do. But we don't have to do that anymore. We don't have to kill each other. We don't have to have 10,000 people a day dying from the results of burning stuff. That's stupid. And at the same time, worrying about global warming and all this.
And don't forget the big fire in China the other day, that explosion that went off. I mean, if you want to see a fire, there's a fire.
Yeah, that's right. But it only killed 100 people, and still 10,000 people died that day from just the results of air pollution.
Yes.
Around the rest of the world. So the 100 people from that is nothing compared to the rest, really. It's just trivial.
As Moran would say, fire is obsolete.
Yeah, essentially, that's right. And when we realize that as humans, and we're going to be pointing at people that are using fire and trying to burn fuels and just go, look at that idiot. He's actually trying to run the fuels in his car. Why would he do such an expensive thing? Why would people waste and burn fuels and hurt others and so on? With the caveman, that'll be the saying in the future, probably. Fire, that went out with the caveman. Here, take my plasma torch.
Can I interject for a sec?
Surely.
I just wanted to let you guys know that Mr. Keshe ran out of battery on his phone. That's why.
I thought something like that happened. He did mention he had to go too. He's a bit busy. So, and speaking of which, I think we should wrap things up here. It's 4.5 hours or something. So that's probably adequate for this time around.
Vince, I'll do what you said.
What?
Oh, just talking to Vince in the back. I'll do what he said. Just if he's listening.
I'm here.
Yeah, I'll do what you said. Okay, all good.
Okay, thank you. I had to think there for a sec what I asked you to do.
and 10,000 people around the world are wondering right now too.
I was wondering myself, but that's okay. But I understand. It's okay. That's good. Okay.
What else? Guess that's about it for now. We've got humanity is ready for deep space travel for tomorrow's 75th Knowledge Seekers Workshop. And part of that is, just as a heads up, it appears that some sort of group will be forming toward working with the lift technology.
Well, as I understood it, that since we've now created materials, that we've now created water, that we've created energy, that that there are people with lift, it's time to put everything together, and that's what this is about. Is time to put everything together, and we're not asking for people to send platforms and chairs and that kind of stuff. As it is my understanding that we will build the materials as we need them.
And my understanding that the craft itself will be a plasmatic structure as much as possible. So we'll try to keep away from the physicality as much as we're able, apparently. So interesting challenge. All righty, let's wrap it up for now. Thanks, Vince. Appreciate that.
Thank you very much.
Thank you, Michael. Appreciate your lovely sculptures today.
Yes, Michael, we'll get in touch so that we can start putting this stuff in the shop. I'm trying to just gather people together, too. So get some good, nice pictures together of the stuff that you'd like to produce or to sell, and then we'll talk about that after.
Appreciate it.
Excellent.
We got to meet up.
Yeah. Rick, can you send me his contact details for Skype?
Yep.
Okay, thanks.
Have a good day.
Yeah, you too.
Okay, and everybody have a good day. This is the end of the August, well, it's August 19th now, but it was the 18th, 2015. Keshe Plasma Reactor Group. Thank you, everybody, for attending. Stop the live stream now.
Thank you, Rick. Bye,
Thank
guys.
you.
Thank you.
Bye-bye. Bye.
Thanks, guys. Have a good
Bye
week.
to all.
Hey, good night, everybody. Hey, Rick, can I get a recording of this on the Zoom to rewatch?
I'm not sure on the Zoom. I don't usually post the Zoom, but I usually post a video.
I really wish you would post the Zoom because it's so much better quality than what you broadcast in live.
Oh, yeah, I can read the fine print. It's just like nothing better.
Well, that's a good idea then.
Now it still says your cloud recording, so can you turn that off and I'll see
cloud recording. I just clicked record and I guess it automatically went cloud recording.
Yeah, they're messing with us there on the back end with